We are working today on the January 2024 Algebra 2 Regents. We are getting ready for the Regents that occurs tomorrow. So I'm really excited about doing this video and being here with you, getting you prepped for that Regents. I just want to be clear. My goal is that to make this Regents video the best video that possible. So I really am. My goal is to get you to a point where you feel as ready as possible. What that means for us is that we are not just doing the problems. I know that a lot of videos out there just kind of do the problems and for 2.5 hours and you kind of expect the, or maybe the teacher or the video maker expects you to osmose it into your brains. But the truth is that if just giving you the answers from day one worked, you would take Algebra 2 for a day and then be done. Or if it worked, it would work the whole year. And it doesn't really work that way, unfortunately. So what I'm going to do, and I do hope that you stick to this video, is that I'm gonna give you time, 1 minute per problem, to actually practice on trying to do the problem on your own. I'm going to give you methods of doing process of elimination so that when you get to a question that you don't know how to do, you can actually learn how to eliminate answers that are incorrect and increase the chance of getting the question right. And sometimes even increase the chance of getting it right to 100%, even if you don't necessarily know how to do the problem. And of course, I am committing to showing you how to do every single problem on the test by hand, except for like, I think there's one problem that you actually need the calculator. That's a part of the requirement. But besides that, every single other problem I'm going to do on paper. All right. So without further ado, this is the Algebra 2 Regents January 2024. There is one comment that I'm going to make about this specific Regents. A lot of times when they're actually switching from one standard to the next, you'll see that the tests get a little bit weird. My teacher used to say that the reason is that the test makers kind of get to fit in all the problems their favorite problems that they didn't get to fit in the beginning. I don't know if that's true or not, but the truth is that there are some weirdnesses about this test. And the first weirdness, before we even get to problem one, I'm going to get to describe it. I know with a lot of students, I always tell them that what the test says here, it says here, let me see if I could highlight this. Note that the diagrams are not necessarily drawn to scale. Okay? Note that the diagrams are not necessarily drawn to scale. It does not say that the diagrams aren't drawn to scale. Okay? In fact, the diagrams are almost always drawn to scale. Most tests have every diagram drawn to scale. A small number of tests have one diagram not drawn to scale. Occasionally, I have seen two diagrams not drawn to scale. And I'm going to snooze my alarm. And I have seen two diagrams not drawn to scale. And but I've never even seen three diagrams not drawn to scale on a test. So what's my point? On a test, if you find that you don't know how to do the problem at all, but if the diagram were drawn to scale, you could maybe make some assumptions, then I would say go do it. But that's first if you have to assume it. Even better than that, just confirm whether it is drawn to scale. And often you could just confirm whether it's drawn to scale. And we'll talk about how to do that a little bit during the test. Now, I said that this test was a little bit weird. The reason this test is a little bit weird is that this is the first test that I've really seen where not only are none of the diagrams not drawn to scale, but or none of the diagrams, not drawn to scale. So every diagram is drawn to scale. But there aren't even any diagrams that could even theoretically be not drawn to scale, which is very weird. But I don't know what tomorrow's test is going to look like, nor does anybody making these videos. But keep that in mind. If there are diagrams that are or are not drawn to scale, first try to confirm whether they're drawn to scale. But if you don't know how to confirm whether they're drawn to scale or not, and you don't know how to do the problem, see what happens if you just assume that it is drawn to scale and see if it helps you. That said, I'm going to move on. Here's problem one, numero uno. A cafeteria food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch in the cafeteria, brought food from their home, or purchased lunch from an outside vendor. This collection of data would be best classified as a census experiment, observational study, or simulation. Okay, so as I said, I am going to give you uh, for every single problem, I'm going to give you a minute to try the problem on your own. And I'm going to start the minute now. In this case, also, that does include process of elimination because you may not be sure of what the answer is, but you may know that some of these answers are incorrect. Okay? So we got 44 seconds left. Do your best to try to think about what these words mean and do your best for that process of elimination. 34 seconds left. I'm going to give you a minute for every single problem that we do. Please do stick to the problem, stick to the process. This is the way that we get the best grade possible. So 20 more seconds. I'm going to be silent for the rest of the 17 seconds and let you practice. All right. Okay, so we are done with that part, that minute. Hopefully you did take your time to practice. I will tell you this, every student who takes their time to practice during that minute will get a higher grade on tomorrow's test. And I fully believe in your abilities to do as well as possible on tomorrow's test, but that does include making your effort, not just watching me do it, but taking your time and your effort to actually try the problems on your own. So first off, is this thing where this process where the cafeteria food manager is asking whether employees purchased lunch from the cafeteria, brought lunch from home, or purchased lunch from an outside vendor? Is it a census, and is it a census experiment, observational study, or simulation? So let's actually just clarify what some of these words mean. And I hope you did eliminate some of these answers. So a census, this is the most common incorrect answer, but what is a census? This is people being counted. This is people being counted. And the people are not being counted. The people are being asked what they prefer. So a census actually counts people. Think about the census that occurs every 10 years in the United States. In the United States, we count how many people there are every 10 years. And that, based on that, we apportion representatives and other resources. So we are not counting the people, we're actually asking them their preference. So that's not it. This one, an experiment. Well, to be an experiment, you have to have a variable that is being, let me use this again, that you have to have a variable that is being modified. To test results. And in this case, the cafeteria food manager is not modifying any variables at all. Okay? So this can't be the answer. He's not modifying any variables at all. He's asking people what they prefer. The next one is an observational study or a simulation. Based on these, you might actually know between choice 3 and 4 which one makes less sense, which one makes more sense. That's why I ask you to do your process of elimination, because the truth is you may not have recalled these definitions from Algebra 2 class. Maybe your Algebra 2 teacher was sick that day and you had a sub or something, or you may have missed that detail. So what about these? What is a simulation? A simulation is an imitation of a real life scenario. This is not an imitation of a real life scenario. This is literally a real life scenario where you're asking people their preferences. So this is not a simulation. And so what is an observational study? Well, in this case, you have a variable being measured, but not independently modified. And you do have that. You have a variable being measured. The variable that you're measuring is their preference for food source. So you're measuring whether they're purchasing lunch at the cafeteria or bringing it from home or purchasing it from another vendor. So it is definitely that. So if you got that, congratulations, you got 2 points on your raw score. And of course, if you did process of elimination, you may have found that you may not have known what an observational study was, but maybe you were able to eliminate the other answers, or maybe you were able to eliminate 2 answers, and that would result in you getting a 50-50 chance of getting it right. Now, why do I mention the 50-50 chance of getting it right? I'll talk about it with this one. Which graph, this is number 2, numero dos, which graph has imaginary roots? Well, choice 1, 2, 3, or 4. Okay, so I'm going to give you that minute. Please do the process of elimination. Do that process of elimination. See what you can get based on the problem. So, which one do you think is correct? Which one do you think is incorrect? The graph has imaginary roots. You guys know what real roots look like, perhaps? And that may help you to eliminate the incorrect answers. Okay, I'm going to give you another 30 seconds. This one is a problem that I think a lot of students would get right, even if they didn't know how to do it, just on process of elimination. Ten more seconds. 5. Okay, so now why do I say make sure to use your process of elimination check and decide on an answer? When you're done with your process of elimination, if you don't decide on an answer, here's what I've seen. I've seen even adults do it, but I've seen a lot of students do it. I even had one student going for like maybe 5 minutes on this trick because they were tricking themselves, convincing themselves that they knew how to do the problem. So what happens is they say, "Oh, I think the answer is 2, but it might be 3." Then I say, "Oh, the answer is 3." "Oh, I knew it was 3." They're like, "Oh no, actually the answer is 2." "Man, I knew I should have chosen 2." And then because in other words, they keep thinking that they knew the right answer by simply not choosing the answer. So you have to commit to one of the answers before you're even allowed to say I was right or I was wrong. If you didn't commit to one answer, this is the answer, it doesn't count. So which graph has imaginary roots? Oh, and I said I would tell you about 50% chance of and why the 50-50 chance of getting it right matters. So I know that this answer has this root over here, which is a positive root, and this root here, which is a positive root. Those are not imaginary roots. Those are definitely real roots. It might be like 1 and 3, or 2 and 6, or maybe 4 and 9, or something like that. Whatever those roots are, these are real roots. So a lot of students who are willing to commit to eliminating incorrect answers would eliminate this answer. And then they would recognize, well, if that one has real roots, this one also definitely has real roots. Maybe the roots are like 1 and -1 or something like that. This one has also real roots. And now there's a 50-50 chance of getting it right. And why is that 50-50 chance so significant? Well, somewhere between 24 and 30 points is the number of points that you need to pass the Algebra 2 Regents in the raw score. Somewhere between 24 and 30 points. There are 24 multiple choice questions. Each multiple choice question is worth 2 points. So if you get half the multiple choice questions right and don't even get anything on the part 2s, 3s, and 4s, you have a very large chance of passing. So if you actually get down to a 50-50 chance of getting it right, that is a passing question, as crazy as it sounds. And if you don't get down to 50-50, but you get down to 1 in 3 chance of getting it right, you're still at a place where instead of getting, wild guessing would get you 6 points, eliminating one answer from every question would give you a 1 in 3 chance of getting it right. That would be 1 in 8 out of 24. So 1 in 4 is equal to 6 out of 24. 1 out of 3, so you eliminate one answer from every question, that's 8 out of 24. But 1 in 2 questions, well, that's equal to 12 out of 24. And that's a passing grade. But notice that just eliminating a choice boosts your grade a lot. So that's the real reason why I say 50-50. Now with this one, why we eliminated these two was because they have real roots. But if you actually look at the choice 3 also definitely has a real root. Okay? And this one is repeated. These are real roots, and these are distinct. And these are also distinct. So choice 1, 3, and 4 can't be the correct answer. But if you notice, choice 2 definitely doesn't have real roots. After all, real roots means are equal to x-intercepts. Real roots and x-intercepts are literally the same thing. Literally the same thing. And in this case, it also means real zeros. Actually, that just always means real zeros. So real zeros, real roots, and x-intercepts are literally the same thing. Choice 2 doesn't have x-intercepts. Now, what about roots, x-intercepts? What about roots and zeros? Well, roots and zeros are just the same thing. But real roots and real zeros just mean that the roots and zeros are real numbers, which is why they're x-intercepts. Anyway, so this is why choice 2 has to be the answer. Okay? I hope that you got this one right. This one is a bit of a what I call a gimme. Give me my points. Give me my points. Why? Because we can actually, even if we don't remember what imaginary roots are, we can actually do a lot of elimination for this question. If you didn't do any elimination and you got it wrong, well, sorry for that. But if you did do elimination and you still got it wrong, then I got to say I do appreciate your effort. All right. But again, if you got it wrong, but you didn't do any elimination, actually, I think you need to take credit for not doing any process of elimination. So at that point, we're going to go to problem 3, número 3. Given 3 is a root of f of x equals x to the 4th minus x cubed minus 21x squared minus plus 45x. What are the other unique roots of f of x? The other unique roots of f of x. Okay, so I'm going to give you a minute. This one is very friendly. If you know a little bit of stuff, there's a lot of ways that you could do this one using process of elimination. So I'm going to give you your minute. I'm going to set up my calculator. That's a hint there. Set up my calculator. "44 seconds. I would think really deeply about how we could possibly eliminate any answers. There are some ways that if you put a little bit of thought into it, you might find you could definitely eliminate some answers. 26 seconds. Another strategy I want to point out with 17 seconds left is that you can actually, instead of eliminating answers by some guessing strategy, you could eliminate answers because they don't necessarily make sense. Okay, so that is our minute. That is our minute. So when I said you could actually eliminate some answers via other methods, like in this problem, I notice that the constant term is 0. Okay? In other words, 4 plus 45x plus 0. The zero, the constant term is literally 0. What this implies is that 0 is a root. That is something that's true only when the constant term is 0. If the constant term is 1, then you got to do work. If the constant term is 20, you got to do work. If the constant term is -8, you got to do work. But if the constant term is 0, 0 is a root. How do I know that 0 is a root? Well, because remember, 0 is the number that you plug into the function. F of 0 is literally 0 to the 4th minus 0 cubed minus 21 times 0 squared plus 45 times 0. Here's a 0. Here's a 0. Here's a 0. Here's a 0. Add a bunch of zeros, you get a 0. So 0 is a root. So by just knowing that 0 is a root, I've said that this is possibly an answer. This is possibly an answer. This is definitely not an answer because it says what are the other unique roots. That choice 1 doesn't contain 0. And choice 3 also doesn't contain 0. So that means that choice 1, choice 2 and choice 4 are the only viable answers. And now we're at a 50-50 chance of getting it right, and we have a passable question. A passing question. A passing question. What is a passing question? A passing question is a question that if we only get down to 50%, this puts us right at the passing mark. We're statistically, whether we get 50% of them right and 50% of them wrong, we're still at a passing grade. And then we only need a few more correct questions to pass. And we'll talk about showing work probably during this question. Notice that what I wrote is actual work. I did work to confirm choice 1 and 3 were wrong via correct math. Does that make sense? Via correct math, okay? So what about, well, then what's the answer? -5 or 0? -5 and 0 or -5, -3 and 0? So I promised that I would do every problem on the on paper, but I will also when a calculator is beneficial, I will also do that on the calculator, okay? So let me turn on the calculator. So what I'm going to do, I'm going to do this one by graphing. I'm going to do x to the 4th, because you can actually see the roots, minus x cubed. And remember that we already know one of the roots is 3. So that's going to serve as a check that we actually typed it right. X squared plus 45x. So now I'm going to zoom standard to graph this polynomial. I see that there's a root there at -5, which confirms that -5 is a root. Okay. I see that over here again. And I also see that 0 is a root. So that confirms that I typed it correctly also. And then finally, there's one more root, a double root at 3. I see that the graph bounces off at 3. So 3 is the other root. I notice here that at -3, right here, there is no root there. So I'm going to bring this over to here. So we know that -5 was supposed to be a root. Why is -5 going to be a root? Because choice 2 and choice 4 both have -5. The only viable answers both have -5 as a root. Okay, they both have 0 as a root, so that confirms that part of this is right. Why does that dot keep disappearing on me? Okay, that's interesting. There is 0, and now there is 3. 3 better have been a root because they said it's a root here. So what about -3? -3 is right there, not a root. Okay, so -3 is not a root. So that one's going to be the wrong answer. But I said that I would promise doing this problem. I promised doing this problem on paper also. So 1, the coefficients of the polynomial are 1, -3, -21, 45, and 0, okay, I am going to do synthetic division with the root. So, but they both have a root -5. Choice 2 and choice 4 both have a root -5, so we know that -5 is a root. Choice 2 and choice 4 have a root 0, which we confirmed to be a root early on. So the only difference is whether -3 is or is not a root. So we could actually test -3 to be whether it's a root or not by plugging it in here. And we get 1 goes down. 1 times -3 is -3. -3 plus -3 is -6. -6 times -3 is 18. 18 plus -21 is -3. -3 plus times -3 is 9. And 9 plus 45 is 54. 54 times -3 is -162. Add these two numbers and I get -162, which is not equal to 0. So this confirms that -3 is not a root of the polynomial. Okay? If -3 were a root of the polynomial, we would get a remainder of 0. So that confirms that choice 2 is the correct answer. I hope you got something out of this. Uh, this is a really important conversation, that process of elimination. And I believe in your ability to get the best score possible in this test and to pass this test and to do super duper phenomenally. But I will say this, you see how problem 3 and problem 2 and problem 1 look? You see how there's work there? I will say this, that see number 4, because I haven't gotten to it yet, number 5, number 6, number 7, number 8. Now, you see how they're all blank? Well, because I haven't done them yet, right? But by the time I'm done with them, I will have shown work. And here's what I'm saying right now. When we get the Regents to grade them, I'm a teacher, so I get to grade them. When we get them, I always, just to look at what the tests look like, I always end up looking at what the part 1s look like. And I always notice that students almost exclusively have the entire multiple choice section blank. Why is that a bad thing? Well, you can't get the question right and boost your score if you're not showing work. I know that students and teachers have a battle in terms of showing work. Should I show work? Should I not show work? I think you need to let the teacher win that one. Show your work. And if you do that, you will get super duper points on part 1. And the truth is that later on, when I got to the part 2s, 3s, and 4s, a lot of teachers unfortunately end up giving up because students are refusing to show work, and they end up giving up and saying students should focus on the part 1s. But the truth is that if you focus on the part 1s and you show work, which means that your score is going to go up, then you should actually put equal focus on the part 2s, 3s, and 4s. And I'll talk about that statistically later, why I know that not enough students are showing work on the part 1s. I'm gonna talk about that after. Let's talk about number 4, numero 4. Given P not equal to Q, P equals 1/2 to the power of Q, expressed in logarithmic form, is equivalent to log base P of 1/2 equals Q, or log base Q of P equals 1/2, or log base 1/2 of P equals Q, or log base 1/2 of Q equals P. Well, I'm going to give you the minute. And if you want a suggestion for process of elimination, my suggestion will be to take test problems. Take a test numbers that you know satisfy this equation. Maybe be smart about your choice of P and Q. Maybe be smart of your choice of Q, and then get P, and then make sure that the answer matches your prediction. Okay? 30 more seconds. I'm going to bring my calculator to the side. Okay, so that is our minute. So I wanna talk about how we could actually do this problem on the calculator. So it is possible, and I'm gonna use my random number generator to actually select which choice I'm gonna test. Okay, I'm gonna choose choice 1 to test. Okay, that was my random number generator. As a teacher, I love using a random number generator. So I am using my random number generator to try choice 1. So but I need to, how do I test choice 1? I need a value of P and Q. I know if Q is equal to 4, I know that 1/2 to the 4th power is equal to, well, 1 over 16. So that makes P equal 1 over 16, and that makes Q equal to 4. Now, I don't know if this is a good choice of numbers, but we could test it. Hopefully, we don't get into a situation where this is, sometimes the numbers that you choose work by coincidence. Log base 1 over 16 of 1 over 2. And according to this, I should get 4. But I don't get 4, I get 0.25. So where did I get that? I went to math, and one of the last options under math is log base. Log base of 1 over 16 of 1/2 is equal to supposedly 4, but it's not. That's 1/4. Okay, so and now that I'm realizing maybe a better choice of numbers would have been like 5 and 1 over 32, but that's for reasons that as a math teacher I know. But if the truth is that if you actually do 2 test numbers, or 2 or 3, yeah, 2 test numbers, you will actually confirm which answer is correct. In fact, maybe you need 3. I think you need 2. I think you just need 2. So, but that one is incorrect. Okay. So now, how do I do this problem? I actually don't do this problem by test numbers. This one actually I use it's a definitional statement. This problem is literally asking us the definitional statement of logs. What do I mean by that? I mean literally, uh, if you have P is equal to B to the n. Okay, this is equivalent to the statement log base B. Notice that yes, log base B of P is equal to n. So notice here, this B is called a base. It was called a base here, and it's also called a base here. That's not coincidence. It's literally the same word because it's literally the same number. So the base on the exponential side and the base on the log are the same exact number. Okay? This up here is called, well, this one is called an exponent, right? So the result of plugging into a log is the exponent. So you plug into a log and exponent comes out. And what about this number P? I use the letter P because of the word power. So the power goes in. The power goes into the log, and then the exponent that would give you that power on the base of the log is the result. Okay? So that means that since this is the base, this is the exponent, and this is the power, and they use the letter P too. That means that log base of 1/2 of the power is equal to the exponent Q. And that is choice 3. So that's how we do the problem. So this one is a definitional statement. If you got it right, congratulations. If you took test numbers, congrats. If you there's a reason why I actually was eliminating choice 1 and choice 2 to begin with, because of this thing that I know, the base and the base, they're the same number. Since the original one had a base of 1/2, I knew that the answer, the log, was going to have a base of 1/2, which eliminated choice 1 and 2. But I didn't do that way because I needed to show how to plug it into a random number generator. That's or into a calculator rather. That said, numero cinco, number 5, which graph best represents the graph of f of x equals x plus a squared times x minus b, where a and b are positive real numbers. So let's get that minute. Use the information that they gave you to answer the question. We have 52 seconds left. This one is, I wouldn't say it's a gimme question, but since they said a and b are positive real numbers, maybe there's something you could do. Maybe using a calculator, maybe using some knowledge about roots that you know. X plus a versus x minus a, x minus b versus x plus b. 23 seconds left. Maybe something about the coefficient, the leading coefficient of f of x. In fact, I'm going to use the leading coefficient of f of x to eliminate some choices. And that is our minute. Okay, I said I am going to use my leading coefficient to eliminate some choices. I notice that f of x is equal to 1 times 1x plus a squared plus times 1x minus b. Let me actually write this because that's a little bit too crowded. So f of x is equal to 1 times 1x plus a squared times 1x minus b. Okay, so the leading coefficient of f of x is 1 times the 1x plus a, so 1 squared, times the coefficient of x and 1x plus b, so times 1. Well, 1 times 1 squared times 1 is equal to 1. So the leading coefficient is 1, which is greater than 0. So we're going to have a cubic. That does this. Okay? Blowing up this way, blowing up that way, which means that eliminates choice 4, which blows up in the wrong direction. And choice 3, because it blows up in the wrong direction. In fact, there is already a reason we can eliminate one of the other choices. They really didn't make this problem as difficult as they could have. There's another reason we could eliminate choice 2, because this one has a root there, another root there, and another root there. Whereas this problem has a, remember b, they told us that b is a positive number, so positive root of multiplicity 1. And then this one, they told us that a is a positive number. So now we have x plus a, that corresponds to a root negative a. So this is a negative root. And this one is at x equals b. This negative root is at x equals negative a. But its multiplicity is equal to 2 because of the x plus a squared, which means this one has a root of multiplicity 2. Multiplicity 2. And this one has a root on the positive side, as we said, of multiplicity 1. So that one is correct, and this one is not correct. So if you used process of elimination, even if you didn't know how to do the problem, you may have actually found that you have reason to eliminate choice 3 and 4 and 2. So process of elimination is a super powerful method of boosting your score. Now, I know that a lot of videos put a lot of self-promotion in their videos. I do very little self-promotion. In fact, this is the only self-promotion that I'm going to put in. And I promise you that this is the only self-promotion I'm going to put in. I promise you, except for maybe I'll mention the tutoring company, JuanTutors.com, maybe very briefly during the video. But my only self-promotion for students, moms, and dads, if you go on, you can go to JuanTutors.com. We are hiring top quality tutors, and we already have a bunch of top quality tutors. And that is the end of the self-promotion. That's it. So, but on the screen, though, I have the word snacks because I did want to talk about snacks. What I recommend for snacks on the test. So hopefully your school is not one of those that really are very anti bringing any kind of snack. I have here a pure protein chewy chocolate chip bar. Now I'm not sponsored by Pure Protein, although if they wanted to get in contact with me, do so. But the reason I do enjoy these bars, first off, I do like the taste. Second, I mean, they have a proteiny taste to them, but the thing is that because they have have a lot of protein, they don't mess with your stomach quite that much, and you don't want to mess with your stomach quite that much when you're in the middle of a test. Although I will say this one, you know, watch out for your nut allergies. Check always in the back to see if the product has nut the potential for nut allergens or not. What else? I have a Fairlife milk. This is chocolate milk, but it's actually lactose free. So for those of you who are lactose intolerant, this is actually a nice option. Okay, and they're delicious. I like the chocolate. I know the vanillas are really hard to get, at least in New York. They're really hard to get, but I actually like the chocolate, so I'm fine with that. Coffee. So first off, an easy to digest bar, like a pure protein. Easy to process. Easy to process. And it's not really about digesting. It's about processing without your stomach blowing up. Pure protein or granola. Okay. And maybe a lactose-free drink. Okay. And now coffee. Coffee is a risky one. Only if you're a coffee drinker. So what's wrong with coffee? Coffee we know helps you stay awake. It gets you energized a little bit. Coffee, though, it has a secondary property of allowing your body to process carbohydrates more efficiently, which you might say, why not process my carbohydrates more efficiently during the middle of a test where I want to process my carbohydrates efficiently? Well, it happens to be that it does so extremely fast. And what ends up happening is you may find that in the middle of a Regents, if you drink coffee, suddenly you're starving, like genuinely, like hunger like you've never felt before because you drank coffee. I know a lot of coffee drinkers will say, no, coffee makes you full. Well, studies have shown that even the people who say that are actually technically wrong. But the thing is that because the thing is that they don't eat because they're full of coffee, and then all of a sudden they have a sweet. But because that's the thing, your body craves sweet things, and you might be in the middle of a Regents and suddenly starving and don't know why, and it's because you drank coffee. Even decaf. If you're not a coffee drinker, do not drink regular caffeinated drinks. You could maybe drink decaf, but even that is a little bit risky. Okay, I would even say that water down your coffee with 50% milk or lactose-free milk, preferably, or almond milk, or whatever it is that you choose. But do not have coffee if you're not a coffee drinker. That'll mess with you too bad. That said, that's my recommendations for snacks. Oh, and finally, meds. I have my Weezer squeezer over here, and because I am asthmatic, bring your meds with you. Whatever meds you take legally, of course, make sure that your parents know that you took them. Make sure that your nurse knows that you have them with you. Just bring those things with you, okay? But on that note, number 6, we're going to move on fast and furious over here. The equations, y equals 3t plus 6 and y equals 1.82 to the t approximately model the growth of two separate populations where t is greater than 0. What is the best approximation for the time t at which the populations are the same? Negative 1.9, 0.3, 5.1, or 21.3? I have predictions. But on that note, I'm going to let you get your minute. I have really solid predictions. I have reasons to eliminate 2 of the answers. Maybe if you're good at your predictions, 3. Yes, I can eliminate 3. That's my advice. This is a great place to practice your process of elimination. 41 seconds. All right? 41 seconds. I said that there was just one problem that needed a calculator, but the truth is, if your process of elimination skills aren't like super duper like mine are, you may not be able to do this one with just process of elimination. But the truth is, this is the calculator question. There's one answer that could be eliminated if you read the question carefully. Could be eliminated in an instant. Now, and this is also a test of your own personal psychology and lack of confidence or a great amount of confidence. One of the things that I teach my students is to know what you know. A lot of times I hear students say, "Oh, I think something is true," when they know it's true, or "I think something is false," when they know it's false. And what that ends up doing is it builds this crazy house of cards where they actually allow themselves to be wrong on something that they absolutely know is a different way. Here, for example, there's one answer that I know that could be eliminated by 99% of students if they're just willing to take the bold step of believing what the problem says and not doubting them and not doubting their own selves in terms of their interpretation of the problem. This one says t greater than 0. So choice 1 is wrong. Now you got a 1 in 3 chance of getting it right. Negative 1.9 is less than 0. It's not greater than 0. So choice 1 is wrong. And I know I've worked with students who are in a situation like this where they see a negative 1.9 and they said t is greater than 0 and they say, "I think that one's wrong, but I'm going to leave it there just in case." Why? It's wrong. It's wrong. It's definitely wrong. So don't be afraid to eliminate the answers that you 100% know are wrong. Okay? So there is another one that I personally have the enough skill to eliminate for myself. Okay? So which one is that? If you notice this line, y equals 3t plus 6, that's a 6. This is a line with a very large slope of 3, right? This function is an exponential with a leading coefficient of 1. Let's try that again. 1. So it crosses all the way down here. And it's going to do this. And by the way, where does your negative 1.9 come from? Because it does cross at negative 1.9. But here's the thing. The function is going to go to, well, 1.82 to the 1, which is just slightly less than 2, right there, at x equals 1. So it's going to cross there before it continues to blow up, which means that the answer can't be between 0 and 1. That actually eliminates that answer. Now, why do I have the capacity to eliminate a third answer? Now, I'm going to tell you my notation. Finally, I'm going to tell you my notation for how I cross out answers when I know they're wrong. I cross out answers when I know they're wrong on the number. And when I think an answer is wrong, I put an X next to it. Next to it on the side, not on the number. If I know the answer is wrong, I cross out the number. If I know the answer is wrong, I cross out the number. If I think the answer is wrong, but I'm not sure, I put an X next to the answer. Okay? I think choice 4 is wrong. Secretly, I know it's wrong. How do I know it's wrong? Because this is a large base, and exponentials blow up fast. In fact, exponentials with a larger base catch up to exponentials with a small base. Even though exponentials with a smaller base also blows up fast, the exponentials with a slightly larger base tends to catch up super fast. Exponentials blow up fast. 21.3 is just entirely too small. This is gonna catch up. It's not gonna go backwards like I just do it. It's gonna catch up pretty quickly. Okay. So that said, how do we possibly do this one without using the guessing strategy that I just commented on? And by the way, I do know enough to say that it does blow up fast enough in just a few steps. Because 1.83, then 1.83 squared is around 3, then 1.83 is around 4, 4.5. Then it starts growing by 1.5 and 2. It grows by a factor of 1.8. So 1.8, then 1.8 squared, which is slightly over 3, then that times 1.8, which is around 5-ish, then that times 1.8 is around 8-ish. I mean, it's going to blow up, and that 5-ish to 8-ish is already increasing by 3. The linear function is increasing by exactly 3, which means that very soon after that point where the exponential is increasing by 3, it's going to catch up to the linear function. Okay? But how do I do this? I literally go, I'm going to undo that graph or ungraph it. I usually preserve everything that I graphed. So 3x plus 6. So I disable the graph as opposed to clearing it. And 1.82 to the power, 1.82 to the power of x. Zoom standard again. Let's see if they cross where we see it. Okay, so they don't cross where we see it. We can go to the table and make an estimate. Table set, let's make it table set auto. And we see that somewhere over, look at the big table over here, somewhere between 5, where the linear function is above the exponential, and 6, where the linear function is below the exponential, the two functions cross. So the answer is between 5 and 6. And if you decide to check your answer by scrolling up all the way down to 21, you see that the exponential function, I mean, it blows up to a silly large level. It's already in the 500,000s by x equals 22, whereas the linear function is just at 72. So the answer is 5.1. Okay? You could also change your window, or you could zoom out. So you could zoom out and then look for the intersection point. So there's the exponential crossing right there. You see that above traces the blue calc in blue, so you press the blue second button and calc. And then you choose the intersect. Okay. The first curve, enter. There's only 2 curves. Second curve, enter. Guess. We do have to guess in this case. So enter. And it crosses at like 5.110131. There it is. Which is choice 3. Okay, that's a little extra, but you see how process of elimination can definitely get us the right answer. Sometimes you just got to pull out the calculator and get the answer right and be sure about it. So, okay. So, número 7, number 7, given y equals negative 2x and x squared plus y squared equals 5, the point of intersection in quadrant 2 is negative 1, negative 2, negative 2, 1, negative 1, 1, or negative 1, 2. And I'm going to start the timer. This is one that can be done with process of elimination really, really well. Okay? Lots of information here that can be used for process of elimination. Okay? 25 seconds. 25 seconds. Think about what you might want to do to eliminate some answers. This is one that can be done by plugging in. Two more seconds. So it is possible, that is our time, that it is possible to do this one uh, on a calculator. You just have to solve for y. It involves some radicals. It involves some plus minus. Okay, but it is possible to do this one on the calculator. Okay, there we go. And so what is this? This is a circle with a center 0, 0. This is x minus 0 squared plus y minus 0 squared equals 5, which is radical 5 squared. So center 0, 0, and radius radical 5. Okay, so that's what we have. We have a circle. I don't know if it'll draw a nice circle for me. Let's see. Hey, look at that. So, and then finally we have the line y equals 2x. This is a line. Okay, slope -2, and b is equal to 0. Y-intercept is equal to 0. So we draw a line with that slope going through the origin, and that's our line. Okay, so if we just drew this rough graph, now granted my rough graph turned really nicely because I had software to like round it out for me, but the truth is, like, if you just did this, maybe a little bit more careful to go through the origin, right? Sort of. If you just did that without the software rounding things out nicely for you, I mean, they said second quadrant. There's our point, right? So that would go a long way towards getting you the answer. Now, that said, one of these answers is not even on the circle, so that one can be eliminated. The other three answers are on the circle. How can we get this answer via the calculator or process of elimination? Literally plugging them in. I'm going to use my random number generator again to choose. I'm going to test choice 2 and see if that answer happens to be correct. Let's plug that into the equation. So let's see, y equals -2x. So we got y is 1 equals -2 times -2. So 1 equals 4. False. That's false. I'll also say this. This answer at least is in quadrant 2. This answer could be eliminated because it's not in quadrant 2. 1 -2 puts it in quadrant 4. Quadrant 4. So that's why that answer is there, because if you plug it in to both equations, it seems like it's correct. Okay? So that's why this is the answer. Hopefully you got that right. Hopefully you didn't get tricked by answer 1. But from there, we are going to move on to numero 8, number 8. The rational expression 2x to the 4th minus 5x squared plus 3x minus 2 over x minus 3 is equivalent to, well, one of these. I'm not going to read them all because you can read them, but I'm going to give you your minute to see if there's anything you could do to eliminate some answers. I'm going to give you a picking test points strategy. That is really, really nice. 20. Sometimes picking a test point that's easy gets you the answer right away, but usually it doesn't. But there's a trade-off. And in 2 seconds, that's the minute, there is a trade-off. Picking a test point that's easy and picking a test point that is difficult, but is more likely to confirm the answer. So if you choose a test point, like, I don't know, 9, something, instead of somewhere between 0, 1, or 2, but somewhere between between 9 or 11 or 10 or 13, this is more likely to eliminate all incorrect answers. Okay? But choosing a test point like 0, 1, or -1, easier test points. What that does is eliminate some answers, but fast. So you lose the ability to maybe eliminate all the incorrect answers. Sometimes you got lucky, by the way, and you're able to eliminate all the answers. But and I'll put a question mark around -1 if you think that -1 is or is not an easy test point. But sometimes it does eliminate all the incorrect answers, but often it doesn't. But it actually does so quickly. So, like for example, if I chose the test point x equals 0, x equals 0. So if I do x equals 0, I'm going to write it up here. X equals 0. I got y is equal to, well, every x term is equal to 0 at x equals 0. Then you get -2 over -3, which is equal to +2 over 3. Okay? So for all of these, I'm going to now let x equals 0. Then y for this one is equal to -12 plus 38 over 3, which is equal to, no, let me be clear here because I don't want -12 plus 38 over 3, which is actually 2/3. So that doesn't eliminate that choice. Okay? This one also equals to 42 minus 124 over 3, which actually equals to 2/3. You see how it didn't eliminate an answer yet? Choice 3 is equal to 18 plus 56 over 3, which is greater than 2/3. I don't care about the actual number. I just care that it's greater than 2/3. So choice 3 is incorrect. And choice 4, so it's easy to think that's not valuable because choice 1 and choice 2 weren't eliminated. Now choice 3 was eliminated. Boom. Now we got a 1 in 3 chance of getting it right. And now choice 4, we get y is equal to -36 minus 106 over 3, which is less than 2/3. It's less than 0. It's less than -2/3. Okay, so actually choice 4 gets eliminated just by plugging in 0. That was fast. So you see, you eliminate some answers and you do that fast. But not only that, you actually see that you could just answer this question by choosing another test point. You could get this answer by choosing another test point. It's either choice 1 or choice 2. I don't know. I mean, I know which one it is because I literally did the work beforehand. But see, this is what my test looks like. But in principle, I don't visually know which one is going to be the answer right away. I see they both have a 2x cubed in front, but the truth is I don't know. I don't know right away. So how did I go about doing this problem? I actually went about it by synthetic division. So the coefficients of the numerator were, or are, 2 x to the fourth minus, now the x cubed term, a lot of students forget the x cubed term is 0. That x squared term, -5, then a 3, and then a -2. And we're going to divide this by x minus 3 with a root 3. And so we got, what do we get? 2, 6, 6, 18. 18 plus -5 is 13. 39. 39 plus 3 is 42. Then 126. And minus 2 is 124. So the answer is going to be 2x cubed plus 6x squared plus 13x plus 32 plus 124 over x minus 3, which is choice 3. So I did it manually because I promised I would, but had I just taken any other test point, likely, nearly 100% chance, any other test point would have confirmed the answer for me. And if I had chosen now 9, 10, or 11, or 10, I like 11 more than 10 even. There's reasons I like 10, but because it kind of gives you the end coefficient that you expect. But I also like 11 because it's easier to type in the calculator. And it's a little bit more random than like a 10. Anyway, so we did that one. Número 9, number 9. The equation of a parabola that has its focus at the point -3, 2 and directrix at y equals 0 is y equals 1/4 x cubed, x plus 3 squared plus 1, sorry. Y equals 1/4 x plus 3 squared plus 1. Y equals 1/4 x minus 3 squared plus 1. Y equals 1/8 x plus 3 squared plus 1. Or y equals 1/8 x minus 3 squared plus 1. So take your minute, which I'm timing. You may find that there are things that you could say that'll eliminate an answer. Even if you don't remember focus directrix, maybe you remember some detail about focus directrix. There is a detail about focus directrix that a lot of students remember that is enough to eliminate 2 choices. None of these have a coefficient that's negative, so they all face up. Ten seconds. All right. Okay. Alrighty. So a lot of students don't remember all the details about focus directrix, but if you did focus directrix at least once, or twice, or 3 times, you might remember a certain detail about how to draw some part of it. So you have your y-axis. Okay, you have your x-axis. Okay, then this says the directrix is at y equals 0. In other words, your directrix is the x-axis. Okay, then your focus is at -3, 2. Your focus is right here. Okay, I'm going to put an F for focus. Now, your focus is not on the parabola, but it's used to construct the parabola. So if your directrix is the x-axis, that means halfway between the focus and the directrix is the vertex. Okay, which means the vertex is right there. And that's the detail that a lot of students remember that will eliminate some answers. So this is -3, 2. Well, if that's -3, 2, and halfway between the focus and the directrix is the vertex, this is the point -3, 1. And that means that your parabola can take your parabolic equation can take on the form y equals a times x minus h squared plus k, or y minus k equals 4p parentheses x minus h. This is the vertex form, and this is the focus directrix form. Let me just erase that. I don't like the neatness here. Okay, so that's the focus directrix form. So what's the vertex? Is equal to h comma k. And then the directed focal length is equal to p. Oh, I said this wrong. Sorry. I almost, let me fix this. So this is sorry, this is the x minus h squared is equal to 4p. I knew there was something wrong because I'm missing the squared, but it didn't hit me until the end. X minus h squared equals 4p y minus k. There we go. So that gives the correct coefficient. So the directed focal length is equal to p. And what is the directed focal length? It's equal to the length of the vertex to the focus in that order. So p is equal to 1. And the vertex is equal to -3, 1. So how do I eliminate two choices without knowing focus directrix form? Well, because if I'm subtracting the x coordinate of the vertex from x, then I'm subtracting -3, or in other words, I'm adding 3. That eliminates choice 2, which this should have a +3, and it eliminates choice 4 because that should have a +3. Okay? So that now I have a passing question, a 50-50 chance of getting it right, even if I don't remember how to do it. So how do I go about eliminating an answer now? Well, if you happen to remember another detail, there's 2 more points on the parabola that we could actually get. This point over here, because if you go 2 to the right and 2 down, that distance is equal, 2 and 2. So this point, -1, 2, and this point to the right here, -5, 2, is also on the parabola. Okay? So you could actually have those 2 test points and plug it into the equation and see which one's right. And I would do that but you can. I promised, though, that I would do all these problems on paper. So if I actually replace the p with a 1, I actually get x plus 3, x minus -3 squared equals 4 times 1 times x minus 1. And so if I divide by 4, no, sorry, not x minus 1, y minus 1. If I divide by 4, I get y minus 1 equals 1/4 x plus 3 squared. And if I add 1, I get that y is equal to 1/4 x plus 3 squared plus 1. Okay, so that's choice 1. So we could get choice 1 either by plugging in the points -5, 2, or we can and plugging in the point -1, 2 and see if that works for choice 3, and it doesn't. Or we can actually get it from the focus directrix form. Usually when they ask for the focus directrix form, they just leave it in focus directrix form, but in this case they did not. But that said, number 10, the 7th term of the geometric sequence, radical 6, -2 radical 3, 2 radical 6, -4 radical 3, ... is 6 radical 6, -6 radical 3, 8 radical 6, -8 radical 3. Take your minute. You might find that you actually do know how to do this problem, and this is not your most common geometric sequence problem that you see, but they do appear in an Algebra 2 test. You might find that you got to actually, for sure, eliminate some answers. I could think of reasons to eliminate every single incorrect choice without even doing every problem, without doing it, you know, the normal way or whatever the normal way happens to be for me. And we'll talk about that in a second. Eight seconds. Okay. All right. So the seventh term of the geometric sequence is this. Of this sequence is what? So I talked about eliminating answers, and I said that I could find ways to eliminate every single wrong answer in this choice in this problem, and that is actually true. One of the things that I teach and tutor my students is that when it comes to multiple choice questions, there's often, without exaggerating, 5 to 10 or more, 20, 30, 40 ways of doing the problem. But also, without exaggerating, there's often thousands of ways of eliminating the wrong answer. And that's not an exaggeration. Thousands of ways of eliminating the wrong answer. Because when you free yourself to eliminate wrong answers via correct math, and I just want to be clear, this is eliminating wrong answers via correct math. Meaning you're not guessing, or I think this is wrong, I think that's wrong because, or I think that's right because. No, I'm saying you 100% confirm that this certain answer is wrong. When you free yourself from having to get it right to just eliminating what's wrong, now you've created a literal infinite number of degrees of freedom to eliminate the incorrect answers. Whereas doing the problem, there's often a shortened number of ways of getting it right. When I say 10 ways of doing it, I mean theoretically there's millions, but I mean at this level of math, up to 10 ways of doing this problem. So how do I do this problem? So first off, I noticed that the sequence goes in order: a positive number, then a negative number, then a positive number, then a negative number, we are creatures of patterns. We cannot lie to you when it comes to you detecting a pattern. We can't. In other words, we have to give you enough terms of the sequence so that you and I both agree that this is the sequence that we're working with. They said that it is a geometric sequence. At that point, they only needed to give you 2 terms, but they gave you 4. That said, when we give you a list of numbers, it has to be that you and I would get that is the most common answer that you and I would get. So the fact that this sequence goes plus minus, and that it's geometric, it implies that the next term is a plus, then the next term is a minus or a negative number, and the next term is a plus, a positive number. So the answer, this is the first, second, third, fourth, fifth, sixth, seventh. That means that the answer is a positive number. And look at that. Without knowing the number, I've eliminated choice 2 and choice 4. If you don't know how to do the problem, start talking about your process of elimination to yourself. Start actually doing that process of elimination. Do they give these formulas on the test? Yes, they do. I saw your question. Do they give these formulas on the test? Many of the formulas are given on the test. And let's look at that. I'm going to bring this over here. Some of the formulas are given to you on the test. This is where we see the formulas. The geometric sequence formula, it happens to be the formula that we're going to use on this problem. So I'm going to take a screenshot of that. But if you notice, there's a lot of conversion factors. There's some area problems: triangle, parallelogram, circle, another circle problem for circumference, prism volume, cylinder volume, sphere volume, cone volume, pyramid volume, Pythagorean theorem, quadratic formula, arithmetic sequence, closed form, geometric sequence, closed form, geometric series, closed form, radians to degrees and degrees to radians, exponential growth and decay. So those are all the formulas that they give you Jaden, I hope I got that right. Or if I didn't, please do let me know. That said, plus minus plus minus plus minus plus is the pattern. So it's got to be either choice 1 or choice 3. So that said, how do we get this answer? So according to the problem, according to the formula sheet, we have this geometric sequence formula. Okay, a sub n is equal to a sub 1 r to the n minus 1. The seventh term, well, that means that n is equal to 7. A1 is equal to the first term, radical 6. Okay, so now we still need r. Well, I'm going to leave that blank for a second. How do we get r? Well, we happen to know that a2 is equal to -2 radical 3. Okay, and in this case, when n equals 2, and again, a1 is equal to radical 6. So we have 2, according to this, -2 radical 3 is equal to a1 radical 6 times r to the 2 minus 1, which is equal to 2r. So we got -2 radical 3 equals radical 6 times r. Divide by radical 6. Divide by radical 6. And now we have to, unfortunately, do some simplification. R is equal to -2 radical 3 over, I'm going to split radical 6 into radical 2 times radical 3. The radical 3 cancels, and I get that this is equal to -2 over radical 2, which is equal to actually negative radical 2. Now, turns out you could leave it as -2 radical 2 over radical 2 because you're doing this on the calculator. So this is equal to negative radical 2. And now we could get A7. Okay? A7 is equal to A1 r to the 6. So it's equal to 6 radical 6 times negative radical 2 to the power of 6. Now, I said that I would do all of these on paper, which is why I am going to do it on paper when I can. But do note that only one of these choices is going to match this number. So if you do, sorry, this 6 is not there. That was a typo. Okay. You do radical 6 times negative radical 2 to the power of 6, you get a decimal. But both of these are also decimals. But only one of these matches this answer. And in fact, 6 radical 6 is less than 18, so that can't be it. 6 radical 3 is less than 6 radical 9, which is 6 times 3, which is 18. So that's how I knew it was less than 18, and the answer is greater than 19. So that eliminates choice 1. But just to confirm that choice 4 is the answer, radical 6 times a negative number to the 6th power, that's going to be equal to 1, times radical 2 to the 6 is equal to 2 to the 3. So this is equal to 8 radical 6. That confirms that this is the answer. Okay. Jaden, I saw your message that I pronounced it correctly. I'm glad I got it. Jaden, thank you for supporting the channel by subscribing. In fact, what I was going to say is that the best way to support the channel, if you feel like I'm providing a service that is useful for you, is just subscribing. Okay. I don't put out, so far I haven't put out any videos really much. I mean, there's some videos that I tried doing but didn't work out other than math Regents. And I'm going to put out some more videos with math Regents, science Regents. I do have a goal of perhaps eventually doing some other pop science videos. I happen to be someone who knows a lot about a lot of things, so I might do some pop science videos If that's what you want, just say pop science in the comments or the chat. If another idea that I've been putting out is investing. A lot now that investing has become very democratized, meaning that you have apps that you can invest in. I was thinking about doing a lot of investing videos. How to invest smartly, how to invest in a way that protects your money. So if you want investing videos, just type in the chat or in the comments investing videos. All right. But that said, numero 11, number 11, a company wishes to determine the cooking time for 1 pound of spaghetti. The company's technicians cooked 1 pound of spaghetti and recorded the time needed for the spaghetti to be ready to eat. Repeating this process 35 times resulted in an approximate normal distribution with a mean of 9.82 minutes and a standard deviation of 1.4 minutes. In which interval should the middle 95% of cooking times fall? 8.42 to 11.22, 7.02 to 12.62, 9.35 to 10.29, or 6.82 to 11.32. So take your time and use some of that process of elimination. This is a problem that you could probably at least eliminate one answer. I know that I will be eliminating two. I'll be eliminating two answers based on the information that's given. Mean 9.82, process of, and standard deviation 1.4. I'll be eliminating two choices. But I'll give you another 30 seconds. I started the time a little bit later. If you happen to have heard of the 68, 95, 99.7 rule, that might help you eliminate some answers. And that's the time. Okay. So which answers am I going to eliminate? So, well, let's talk about what the 68, 95, 99.7 rule is. 68, 95, 99.7 rule. Okay. What is that rule? When you are in an approximately normal distribution. Now, I'm going to use some big people letters. The big people letters is this funny looking M. That's actually a mu. Those of you who are Greek, and I know we have a big Greek population in New York, so shout outs to you. This is the Greek letter mu, which we use to represent the mean. And sigma is also a Greek letter. It's the mu is the Greek letter version of the letter M. That's why we use it for mean. And a sigma is the Greek version of a letter S. And this stands for standard deviation. Okay? So we use the letter mu for the mean and sigma for standard deviation. Okay? Then, what is the 68, 95, 99.7 rule? Well, 68% of the data is within 1 sigma of the mean. So in other words, between the mean minus sigma and the mean plus sigma. And then the 95% of the data is within 2 sigma of the mean. So mu minus 2 sigma and mu plus 2 sigma. And then 99.7% of the data is within 3 sigma of the mean. So mu minus 3 sigma and mu plus 3 sigma. Okay, so now they asked for 95% of the data in what interval that is. So that's going to be this one, mu minus 2 sigma to mu plus 2 sigma. Now, why did I say I'm going to eliminate two choices? Well, first, the standard deviation is 1.4. and that means that 2 sigma is equal to 2.8. This is too close to the mean. Too close to the mean. So that's not it. Okay? So, but I'm saying that I could eliminate another one. So how can I possibly eliminate another one? So this one, number 4, I know that the 68, 95, 99.7 rule is symmetric around the mean. And 6.82 is 3 away from 9.82, but then 11.32 is 1.5 away from the mean. This one is not even symmetric around 9.82. So that one just, I eliminated that one from the get-go. So now I'm left with 2 other choices. And I have a strong suspicion, fake student me has a strong suspicion that this one is not right and that this one is right. So what do I mean by fake student me? I haven't used that expression in this video yet. Usually I get to say that expression like by problem 1 or problem 2, but real teacher me or real tutor me is the person who explains to you things and also the person who actually is actively doing problems. Fake student me is me simulating myself as a student. When I'm simulating myself as a student, I may not be 100% sure, visually speaking, whether choice 1 or choice 2 are the right answer, but I feel like 8.42 and 11.22 are a little bit too close to the mean, and that's why I suspect that the second answer is the right answer. Notice my X next to the answer, because I think it's wrong, and my checkbox next to the answer because I think it's right, as opposed to crossing out the answer when I know the answer is wrong, and maybe circling the answer, that's a hint for later, when I know the answer is right. Okay, so what is the answer? So I know that I'm in the 95 percentile, so I need mu minus 2 sigma and mu plus 2 sigma. Okay, so that means that I need 9.82 minus 2 times 1.4 and 9.82 plus 2 times 1.4. Okay, I literally go to my calculator, and this is going to confirm. I'm going to do one side, which will tell me what the right answer is, and then doing the other number will confirm that I did it right. So this has both the answer and the check. So 9.82 minus 2 times 1.4, I should get 7.02. I do. And now the second number better be 12.62. And that'll confirm that I did it right. 9.82 plus 2. Actually, I'm going to also show you that I could just retype it by going to the previous line and letting it type it for me. That's a good piece of advice because it's a way to quickly type something. Okay, and I get 12.62. I do get that this is definitely the correct answer. Where does choice 1 come from? Well, choice 1 is 1 sigma away from the mean. That means that 68% of the data is contained within choice 1. Okay, I mentioned the 95% rule also because almost every problem that they'll ask for on the Algebra 2 Regents is going to be a 95% question. So keep that one in mind. That said, numero 12, number 12, given that f of x is equal to 2x squared plus 7x minus 15 and g of x equals 3 minus 2x, what is f of x over g of x for all defined values? Negative x minus 5, negative x plus 5, x minus 5, x plus 5. Such a friendly problem if you're willing to do some work. Any work, almost any work that you do is going to be correct. Let me rephrase that. Any correct work that you do is going to be towards the correct answer. So if you know how to do the problem, just do it. If you don't know how to do the problem, but you have a suspicion, like for example, graphing it, and you feel like that might help, do it. Do it. We got 29 seconds left. Ooh, my legs are sore. Went to the gym yesterday. Good question. A good question. Is it worth going to the gym the day before a Regents? Of course, I'm not taking the Regents, but I would say go to the gym the day before the Regents if you're used to going to the gym the day before the Regents. If you have some nervous energy that you gotta work out, do that. But you might trick yourself into thinking that that's the best strategy when in fact you're actually doing some avoidance strategies. And I have seen, I've actually known students, I've known students at the graduate level saying, I need to work out some nervous energy. Let's play a game before we start studying. And suddenly, and that's like at 6 o'clock. And then it's like 8 o'clock or 9 o'clock and they're playing a game till 9 o'clock when the Regents or their final is tomorrow. So I would advise you only go to the gym if it's very early in the day and the soreness won't bother you. I like being sore. I know that I'm doing something right at the gym. I'm at the right level of soreness and the right kind of soreness, but you know, that's up to you. That said, f of x is that, g of x is that, and they want f of x over g of x. This is one where plugging in a number is really helpful. If I plug in x equals 0, and this will confirm the answer, f of 0 over g of 0. I mean, I'm not saying that this one plugging in will confirm the answer, but we get negative 15 over positive 3 is negative 5. And if we plug in x equals 0, we get negative 5 here. We get plus 5 here, confirming that that one's wrong. And we get negative 5 here and plus 5 here, confirming that that one's wrong. So now we have a chance of getting it right that is 50-50, which is a passing problem. This is now a passing problem. Even if we don't get it right, statistically, we're in the realm of passing. So that's super duper. Now, these two are very different from each other. One has a slope of -1, the other one has a slope of 1. And you might actually notice that the leading coefficients are 2 and -2. The leading coefficient of f is 2, the leading coefficient of g is -2. So when you do the quotient, you're going to have a leading coefficient of -1, which is making this one look really good and this one look really bad. But I did say that I would do this problem, all the problems by hand, which is why I haven't yet circled -1. I also noticed that these are all polynomials, which means that 3 minus 2x has to be a factor of the numerator. Which is actually a very useful fact. So 2x squared plus 7x minus 15 over 3 minus 2x equals, again, these are all polynomials. That implies that 3 minus 2x is a factor of the numerator, which means I could use that as a factoring tool. But I'm going to do 2x minus 3. Why did I do 2x minus 3? Because I find it easier to factor when the polynomial has a positive coefficient. I find it easier to factor with all positive coefficients, all positive leading coefficients. And 3 minus 2x. I know that that's going to be a factor because 3 minus 2x is a factor. And then the factor pair is 1x. And then -3 times 5 is is equal to 15, -15. So now 3 minus 2x and 2 minus 3x, they're differences, they're opposite differences of each other. So I get a 1 and a -1 when I cancel those out. And I get, so this is equal to -1 times x plus 5. I could distribute the -1 in there, and I get -x minus 5. And that confirms that's my answer. Again, though, I tried x equals 0, try x equals 1 to finish it off, try x equals 2 to finish it off. Try x equals 9. That might get you the answer right away. I think it would get you the answer right away. Try x equals 11. That would get you the answer right away. You don't have to plug in the number that I like, which is 0, because I like to eliminate answers fast and then try something else. You could just plug in 11 right away. And maybe I'll do that. Maybe I'll do that on a future problem. I didn't plan on doing that on a future problem, but it doesn't hurt. I don't know what's coming next in a future problem. Oh, this one. I could try it in this one. Anyway, so I'm going to plug in some crazier numbers for this one. Which equation is equivalent to p equals 210 x to the 4/3 y to the 7/3? Is it p equal cube root of 210 x to the 4th y to the 7th? Or p equals 70 x to the xy squared cubed root of xy? Or is it p equals 2 10 xy squared cubed root of xy? Or is it p equals 2 10 xy squared cubed root of x cubed y to the fifth? That's a lot. But I'm going to give you your minute. I'm going to tell you right now, I I always do these on paper, so I am going to do this on paper, but I just want to show you that plugging in weird numbers can get you the answer lickety split. So we got 45 seconds. If you don't know how to do this problem, get your calculator out, start plugging in numbers. Get your calculator out, start plugging in numbers. By the way, if you're wondering what app I'm using Wabbit Emu. But there's also the calculator Calculate 84. And Wabbit Emu is available on Android, and it's also available for Windows computers. And Calculate 84 is just available for all phones. So, and Calculate 84 is a nice app. It's got ads on it, but it, you know, it has its benefits and drawbacks. It's better. It has, you know, touchscreen capability, whereas your actual calculator on your test does not have touchscreen capability. So most of my students, though, don't even use the touchscreen capability so that they get accustomed to doing things the way they would on the test. Okay, so I'm going to show you that I could do this problem by plugging in numbers. I'm going to let x equal 9 and y equals 11. So the original problem then would be equal to 210 times x, which is 9 to the power of 4 over 3 times 11 to the power of 7 over 3. And I get this weird number. And I'm not saying that I don't get a weird number. But the thing is that the correct answer is the only one that's going to give me that answer. So I could try, if you could do process of elimination, there's some answers that I know I don't need to try. But I'm going to use my random number generator to purposely let it choose which one I'm going to try first. So it tells me to choose choice 4 first, and whether that one's right or not, 210, x is 9, y squared is 11 squared, times the cubed root. Let's see if I can find the cubed root. Here's the cubed root. Or I press the math button, and there's the cubed root, and there's the x root. You could do any root you want. Let me do any root I want. Cubed root of x to the third, so 9 to the third, times 11 to the power of 5. And that's not the same number as 105,7934.807. Not the same number. So that confirms that this answer is not correct. And if I go through every single choice, happens to be that my choice of x equals 9 and y equals 11 will confirm the other answers are wrong and that the correct answer is right. So plugging in and doing it that way is a valid method of doing the problem. Again, the reason I'm doing the problems on paper is that there is a benefit to learning how to do the problem manually. Obviously, you're not going to get 100 if you don't know how to do the problem manually. The thing is that this is what my test looks like. Let's see if it gets, there we go. This is what my test looks like with all of this writing. The only reason I have maybe twice as much writing as you should have is because I'm also making notes of what I want to tell you while I'm teaching you. So there are some like long sentences that I am saying, oh, I want to remember to tell you this as the tutor, but you might not be doing that, right? But that doesn't mean that your answer should be blank. Like your answer should look like, here is my number 8. Your number 8 should look something like that. It's actually reasonable. Your number 7 should look something like that. So if you find that you're not writing at all on your problems, you're not showing enough work. Okay? Let your teacher win that battle. They're actually right about showing work. So that will get you the right answer. But now, how do I do this manually? Why do I eliminate choice? Well, I actually eliminate choice 1 because the cubed root, this is a place where a lot of students get this wrong. They see the cube acting on the x, and they think that it acts on the 2, or they see the 4/3 acting on the x, and they think that it must act on the 210 also, or the cubed root must act on the 210 also. But it doesn't. According to order of operations, exponents go first, and then multiplication. So exponent is on the x, it only acts on the x. There's no parentheses around the 210x, so the 4/3 only acts on the x, the 7/3 only acts on the y, and the 2/3, the 210 is not being acted upon by any exponent. That eliminates P, choice 1. That also eliminates choice 2. There's nothing that turns a 210 into a 70. In fact, where 70 comes from is that students just turn an exponent into a multiplication, and that's not how exponents work. Exponents are exponents. Multiplication is multiplication. You don't turn the exponent number into a multiplication number at the base. You don't move things down to the base for no reason. So that actually does eliminate choice 2. So choice 4 really is only the only viable answer, but let's work through it. P equals 210, x to the 4/3, y to the 7/3. And well, that's equal to 210, x to the 1 plus 4/3, plus 1/3 rather, times y to the 2 plus 1/3, which is equal to 210 x squared, no, x to the 1, y to the 2nd times x to the 1/3 times y to the 1/3. And this is equal to 210 xy squared. Since these two factors, x to the 1/3 and y to the 1/3, have the same exponent, you can combine them, xy to the 1/3, which is then equal to 210 xy squared. The 1/3 power is the same as the cubed root of xy. And that confirms that choice 13 is correct. Okay? Now, I chose a random number to choose a random choice. I would have easily chosen choice 3 if the random number generator told me to try it on choice 3. I would recommend not struggling too much on which one you choose. If you know that choice 1 and choice 2 is wrong, then start with choice 3 and then choice 4 to plug in numbers. Same thing happens here. Let me see if this was one of them. Yeah, well, yeah, same thing happens here. Like if you actually wanted to just try some choices, you could start at choice 1, then choice 2, then choice 3, then choice 4. Or you could eliminate answers you know are wrong and then go backwards from 4, 3, 2, 1. Or literally anything you want. You could start with the answer that you think is more likely to be right. Or you can go with the answer that you think is more likely to be wrong. Honestly, doesn't matter. Or you can do another thing, which is test all of them, if you feel like you have enough time to do all of them. Okay? I saw the question, do I have any resources for students? Yes. If you go into the description of this video, there are 2 resources. One is I have a completely free, cost-free practice SAT, ACT assignments for literally every single day, 20 minutes a day. And that lasts the whole year. Literally 366 days in the year, because I know some years are leap years, including this one, and including 4 years from now. And they're free, and they're going to be there forever. So I would recommend going to that link and signing up for that. It's literally 20 minutes a day. And the other thing that I have, and this is for both students and teachers, I know that for students, your Regents is tomorrow. There is a link to a 35 different PDF practice sheets of old Regents problems for Algebra 2 Regents. So for you, if you're watching this and your Regents is tomorrow, that might be a good thing to download after this video is over. And if on the other hand, you're actually watching this after tomorrow, then you could start with those sheets and start literally learning how to do all of those problems. And if you actually get all 35 sheets known, 35 sheets compared to 180 days of school, 35 sheets is a very shortened curriculum. And I can guarantee you that if you know how to do all 35 sheets, you will do very well on this test. If you know how to do all 35 sheets, in fact, I would bet money that you could get a 90 or better. All right. Número 14, number 14. The average cost of a gallon of milk in the United States between the years of 1995 and 2018 can be modeled by the equation P of t equals negative 0.0004 t cubed plus 0.0114 t squared minus 0.0150 t plus 2.6602, where P of t represents the cost in dollars and t is time in years since January 1995. During this period, in what year did P of t reach a maximum? Was it 1995, 2013, 2014, or 2018? Now, this is one that could be done by process of elimination and plugging in. So I'm gonna give you your minute. There we go. But this one can be done by plugging in process of elimination of one of the many methods that are viable. Okay. 1995, 2013, 2014, 2018. Before even plugging in, I could eliminate one of the choices. I see that and I also see that one of the choices is very far from the others, and 2 and 3 of the choices are very close to each other. So maybe visually I can't eliminate that so easily, but one of them I could definitely eliminate. We want to know what year did it reach a maximum. 18 more seconds. Okay, so which answer did I say that I could eliminate? I have a strong to begin with, I had a strong suspicion that 1995 was going to be the wrong answer. So why do I eliminate choice 1? So this does involve, knowledge that I have. I have been a math teacher for, this is my 15th year. I've been tutoring math now a quarter century. That's insane. So given that I'm only 42, so there are things that I'm aware of that I'm more comfortable with than maybe a lot of students, but maybe if you can get this awareness too, it may help you. I noticed that the coefficient of the of t and the coefficient of t squared are close to each other, whereas the coefficient of t cubed is smaller, way smaller. And these are similar. So what that means is this. Initially, the price is going to go down because the linear term dominates close to 0. But because the coefficient 0.0114 and 0.0150 are close to each other, the quadratic term is going to dominate really soon after. Literally in 1997, the quadratic term is going to dominate. And the quadratic term being positive is going to dominate. The quadratic term is going to dominate for a while. And being positive, the price is going to increase from like 1996, 1997 on for a little while before the cubic term, which is a negative term in this case, starts to dominate again. So the max, so the graph is literally, it's going to go like this, but very soon after, go up until it reaches a maximum at some point. So this is 1995, and somewhere here is one of the other 3 years. So I actually know that 1995 is wrong, but that took a little bit of knowledge of being very comfortable with the coefficient. So if you didn't see that, that's okay. But as I said, this one can be done by process of elimination. So t equals 0 in 1995. That means that I could get the t value by subtracting the year minus 1995. So in 2013, t equals 2013 minus 1995, which is 13 plus 5 is 18. 2014, well, t equals 2014 minus 1995, which is equal to 14 plus 5 is 19. And 2018, t equals um, 2018 minus 1995, which is equal to 23. And I could literally do this by plugging in. I am, as I said, whether the random number generator tells me to choose the correct answer or not, I'm going to plug in the one that it chose, and I'm going to choose choice 3. So t equals 19. I'm going to plug that in. I got p of t equals, I'm not going to write it out. I'm going to literally type it out. T equals 19. Okay. And I got to test another one to compare, right? Negative 0.0. Actually, I'm not even going to do it that way. There's a better way to do it. I'm going to stop that from graphing. Because there's a better way to do it, because I'm actually going to do it by graphing anyway. Negative 0.0004 x squared x cubed plus 0.0114 x squared minus 0.0150 x plus 2.6602. Let's go to the table. And we see, just to confirm that 1995 was wrong, 2.6602, then we see a slight drop. Look at the bigger one. Let's make this a little bit bigger. We get a slight drop, like we said, but then it increases right away. And it's increasing, so 1995 was not a maximum. Still increasing, 25, 34, 343, 351, 358, 365, 370, 373, starting to level out, 375, 374. There is our maximum right there. And then let's just confirm. So that's 18. So that's 2013. Let's just confirm. I had a feeling it was going to be one of those two, choice 2 and choice 3, before I plugged them in, because they're one away from each other. That's the reason. That's me knowing test makers at that point. They're one away from each other. So if you know test makers, they're one away from each other. Wouldn't be surprising if that was one of the answers. So, but now it's dropping, and let's confirm that when t equals 23, we're actually significantly lower. Or not maybe significantly lower. This is 23. Still dropping, still dropping, still dropping, still dropping. Okay, so that's how we plugged in, and we confirmed that choice 2 was the answer. How did I do this when I did this on the calculator? I actually went to the graph. So it goes up, and then it peaks right there. And what I did, I calculated in blue above trace in calc. So I press second and then calc. And then I'm going to calculate the maximum 4. I got to go to the left of that maximum. Enter. I got to go to the right of that maximum. Enter. I got to guess at the maximum. And I get 18.3. So that's around 18. So that's somewhere in that 18th year, which is 2013. Okay. So this one can be done in a lot of different ways, and we did this problem in a lot of different ways. If you do appreciate that, and if you feel like that question helped you for tomorrow's Regents, please do hit that subscribe button. Literally, I'm doing this for free because I believe in you having a right to free education and free access to what I provide. I literally, when I was younger, I tutored for like $10 an hour, then like $40 an hour, and I still was able to tutor people who were in my income level when I was a child. When I was a child, I mean, I remember, I ate pizza almost every day, but also pizza was less than $1, and, we ate, one thing my mother never sacrificed in was food, but there were other places that we didn't have access. And one of those things was tutoring. We did not have access to tutoring. Because we weren't even close to affording it. The first time my mother ever made $10,000 in a year was my 18th birthday. And so, not surprisingly, and my stepfather was a chef, and he provided for us as well, but we were just not bringing in that much money. So I always felt bad that as I started increasing my fees for tutoring, and I do tutor now for very discerning clients. Not when I started increasing my fees for tutoring, a lot of clients who lived like I used to no longer had access to my tutoring. So I've always wanted to provide something for free. And this is me providing something for free. So if you do appreciate the help that I'm providing you, then the only thing that I'm asking from you is the subscribe button. And you're not going to be bombarded with a ton of videos because I am really only putting out videos for Regents right now. There are going to be probably finance videos or science videos that you may enjoy too. And if you don't want to watch those, you don't have to. But you're not going to be drawn to the videos. So I do appreciate your subscribe. Number 15, the temperature F in degrees Fahrenheit after T hours of a roast put into the oven is given by the equation F equals 325 minus 185 e to the negative 0.4 T. What was the temperature of the roast when it was put in the oven? Was it 325, 200, 185, or 140? There's a lot of questions that they could ask around this equation. It helps to be comfortable with this equation. But that said, I am going to put my stopwatch for the minute. And take your time to do some process of elimination. You may find, just based on some logic, that you may actually be able to eliminate more answers than you expected. 45 seconds. I know one answer I'm going to eliminate pretty quickly. I'm going to use limit notation for those of you who know some big people math and know limit notation math, but let me put that there. Limit as t approaches infinity. So the limit as t approaches infinity. In other words, if you just leave the roast in the oven forever and ever, which is not safe, 325 minus 185 e to the negative 14, negative 0.4t. Well, this piece goes to 0. So this product goes to 0. So this goes to 325 minus 0, which is equal to 325. That's if you leave it in the oven forever, it gets closer and closer to 325. So 325 is not going to be the answer. That's if you leave it in the oven forever. Okay? That said, this question could ask you a lot of things. They could ask you what's the initial temperature when it was put in the oven. They could ask you how long it takes to get to 300 degrees or 160 degrees or whatever they wanted to, or 200, whatever they wanted to. At what point will it be within 20 degrees of the maximum temperature possible, or something like that? There's a lot of questions that they could ask you. So in this case, when the roast is put into the oven, that means that t equals 0. That's the very first moment that the roast is put in the oven. Okay. So t equals 0. F of 0 is equal to 325 minus 185 e to the negative 0.4 times 0. Okay. Now, where a lot of students get 325 and did what I just did and still got 325 is that they think that e to the 0 is equal to something else other than what it actually is. 325 minus 185 times e to the 0, but e to the 0 is equal to 1. So 325 minus 185 times 1, which is 185, and this is equal to, let's see, 140. So there's our answer. That's our answer. Other answers might be gotten by, putting in the wrong value of t. Might be putting in t equals 1. If you put in t equals 1, you got the wrong answer because t equals 0. So it says t hours after the roast was put into the oven. So when the roast is put into the oven, that's 0 after the roast is put into the oven, right? If you put the roast into the oven at, let's say, 8 o'clock in the morning, and then you check your clock at 8 o'clock in the morning, or right after you put the oven, it didn't suddenly turn into 9 o'clock in the morning. You didn't lose an hour. It's still 8 o'clock in the morning. That's 0 hours after. So t equals 0. All right. Número 16, number 16. I'm gonna enjoy teaching you this one because a lot of students don't even know you could do this one on a calculator. The roots of the equation 0 equals x squared plus 6x plus 10 in simplest a plus bi form are negative 3 plus 2i, negative 6 plus or minus 2i, negative 6 plus or minus I, negative 3 plus or minus I, or negative 3 plus or minus I radical 2. I'm going to enjoy plugging this one into the calculator because a lot of students, like I said, don't know that you could do this on a calculator, but 56 seconds. I'm going to give you 56 seconds, some process of elimination. A lot of students know how to do this problem if it looked like this, literally where no multiple choices are there. And then they get it wrong when it's a multiple choice question because they've conditioned themselves to not show work at all. And they get it wrong. A lot of my students get this one right till they get a multiple choice question. Till they get a multiple choice question. In other words, they get it right when it's a part 2, get it wrong when it's a part 1. Well, what's the trick? You should just do it the same way you would if it's a part 2. You should so work. 5, 4, 3. All right. And Jaden asked earlier if the formulas are in the back of the test, right? Some formulas, as we know, are in the back of the test, but not all, right? So where is that test? There we go. Just bring that over again. So one formula, though, that you could use to get the roots is the quadratic formula. And that actually is what I am going to do. I am going to do this one by the quadratic formula, but first, before anything else, I want to teach you that you can actually plug this into the calculator. And I'm going to use my random number generator. It hasn't made me test the correct answer yet. So this one is going to make me choose a test choice 2. But how do you plug this into the calculator? A lot of students are like, you can't plug in I into the calculator. And then they never looked at the blue things, and above the decimal point is I. I'm going to take a screenshot of this. Above the decimal point. Above the decimal point right there. You see it? Expand this right there. There is an I in blue. So if you press the blue second button, you have an I. Okay, let's quit that. Clear that. Let's just confirm that there's an I there. Okay, I, that's I. So I'm going to test choice 2. I'm going to test, because the random number generator told me to test that one, negative 6 plus I. And the reason I use my random number generator to choose which one I'm testing is that I don't want to introduce bias by choosing the one that I want, you know, like that I think is somehow better to test. So I'm going to test that. Let me see if I could do this over here, and then make this a little bit bigger so you could see it a little bit better. So I'm going to test the polynomial with negative 6 plus I. So I got an x squared. That's negative 6 plus I squared plus 6x. So plus 6 times negative 6 plus I. And plus 10. Let's see if we got 0. No, we don't. 9 minus 6i. So was that 9 minus 6i? Yeah, that was 9 minus 6i. So this confirms that 9 minus 6i. Well, that choice 2 is not the right answer. Okay. They're actually, by coincidence, that is the one problem that I would have eliminated right away, because negative b over 2a is equal to negative 6 over 2 times 1, which is equal to negative 3, which means that negative 3 has to be the average of the two roots. And so you're going to have a -3 as the real part. Okay. But the other three choices have a -3. So you could do the same thing for the other choices and just test it until you get 0. And that'll be the right answer. Now, how do we do this on paper? Because I promised this is a 1, A equals 1, B equals 6, C equals 10. And we have the quadratic formula, right? This is getting crowded here, but x equals -b plus or minus square root of b squared minus 4ac all over 2a. So this is equal to -6 plus or minus the square root of 6 squared minus 4 times 1 times 10 all over 2 times 1. All right, so equals -6 plus or minus the square root of 36 minus 40, which is equal, or over 2, which is equal to -6 plus or minus the square root of -4, hinting that the roots are definitely imaginary, over 2, which is equal to -6 plus or minus radical -4, so you got 2i. Radical 4 is 2, so radical -4 is 2i. All of that over 2, which is equal to -3 plus or minus 1i, which is equal to -3 plus or minus I, which is choice 3. And now you know that you could have done this problem just plugging in and checking. A lot of students don't even know that that button exists. I've tutored really high-level students taking calculus in, I have not yet found one student who actually knew that that button existed. Now you know that that button exists, and you can get a super duper score on your test just by knowing that. Okay? Like, for example, one of the questions that they love asking is, like, what is the value of I to the power of, usually something involving the year, so 2024. Now, I know that 2024 is a multiple of 4, because 24 is a multiple of 4. So I to the 2024 is I to the 24, which is I to the 0, which is equal to 1, and the calculator confirms that. I to the 0, I to the 2024 is equal to 1. Now let's talk about this answer. Why is it 1 plus 2.24 times e to the -11i? So the thing you have to know is that the calculator doesn't follow a rule. The calculator actually calculates I to the 2024 power. And that algorithm that it uses what's called floating point arithmetic. And so it actually adds the tiniest error into the answer. So you need to know, and this is an unfortunate part of the technology. You need to know when you get a decimal as small as e to the -11, that's 0.0000000000224, that actually means 0. And it's, again, really unfortunate that you need to know that, but it is true. So that's 1 plus 0i, or 1. I to the 2024 is equal to 1. I to the power of next year, 2025, is I plus this weird, tiny, real decimal, so 0 plus I, also known as I. Now you know how to do that. Número 17, number 17. Which equation does not represent an identity? Is it x squared minus y squared equals x plus y x minus y? Or is it x minus y squared equals x minus y x minus y? Or x plus y squared equals x squared plus 2x plus y squared? Or is it x plus y cubed equals x cubed plus 3xy plus y cubed? Some of you already know the answer. Some of you don't know the answer for one of the identities. But you do know the answer for 3 of the other ones. So you can definitely get this question. I'm going to give you another 40 seconds to get this answer. And again, if you don't know which one the identity is, and you need to do something like plug in, okay, then do that. Plug in. Like, remember I chose x equals 9, y equals 11? That'll do it. You could do x equals 9, y equals 5, x equals 9, y equals 8, 10, and 11. I mean, whatever you choose, you'll probably confirm what answer is incorrect. Which equation does not represent an identity? Although I will also say this. do take this opportunity to learn these identities. I highly suggest writing them down when I write them down. Um, if you happen to know some of these answers, use process of elimination and then choose an answer. You got 8 seconds left. Choose an answer saying, I'm committing to choice blank to say that this is the correct answer. Whether you know the answer or not, you have to commit to one before I go over it. Okay, so the identities, p squared minus q squared is equal to, a lot of students get this one wrong. This is equal to p plus q, p minus q. They try to distribute out the exponents over subtraction. Exponents do not distribute over subtraction. Multiplication distributes over subtraction. Exponents distribute over multiplication, but exponents do not distribute over subtraction. Okay, then there's this one, p squared plus q squared. A lot of students get this one wrong, and Algebra 1 students don't even do this one. This one does not factor over the real numbers. It's p plus iq times p minus iq. Then there's p plus q squared, which is the one that they get wrong, right? They put it in the second line when in fact it belongs in its own line. P squared plus 2pq plus q squared. And then also p minus q squared, which is the one they put in the first line when it belongs in its own line, p squared minus 2pq plus q squared. Those are the 4 identities that we need to know. And if you notice, choice 1 is an identity that we should know, is an identity, and we're looking for does not. Choice 2 is an identity, choice 3 rather, is an identity, one that we should know, so we eliminate that one. Now, what about choice 2 and 4? Now, choice 2 and 4, choice 2 doesn't look like the second one, but choice 2, they literally just they just expressed the square as a product. So it is an identity. And then choice 4 is the one that's incorrect. Choice 4 is the one that is not an identity. If you do x plus y cubed, that's equal to 1, 3, 3, 1. Let's do x cubed, x squared, x to the first, and x to the 0. And then y to the 0, y to the 1, y to the 2, y to the 3. And then there's a plus in there, so plus, plus, plus. So this is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay. So that's choice 4 is the one that's not an identity. That's a false application of the x plus y squared identity. And had you plugged in like x equals 9, not y equals 11, you would have gotten it, you would have confirmed that choice 4 was wrong. Is there anything else we could have plugged in? I wonder. 1 and -1. Yeah, there's a lot of other choices that you could have confirmed. But that said, let's go to número 18, number 18. 2 surveys were conducted to estimate the proportion of teens who use social media at least 1 per day. The first survey has 100 samples of 5 teens with a frequency and proportion of teens who use social media with a mean of 7.32 and a standard deviation of 0.207. And then the second one has 100 samples of 50 teens. That's a lot, 50, with a frequency table from 10 to 30, mean of 0.742 and a standard deviation of 0.057. Okay, with the labels, frequency, and proportion of teens who use social media at least 1 per day. Notice that I read the chart, but I didn't absorb everything completely. I actually, whenever I look at a chart, I absorb it as much as it does absorb, but I don't intend to absorb on the first reading. Then I read the rest of the problem, then I go back to the chart. So now I go to the problem. Based on these results, it was determined that approximately 75% of teens use social media at least once per day. What is the best explanation of the difference in the results between those 2 surveys? Is it that the smallest sample size of 5 teens resulted in a smaller margin of error and should provide more accurate estimates? or the smaller sample size of 5 teams resulted in a bigger margin of error and should provide more accurate estimates, or the larger sample size of 50 teams resulted in a smaller margin of error and should provide a more accurate estimate, or a larger sample size of 50 teams resulted in a bigger margin of error and should provide a more accurate estimate. Now, I'm going to give you your minute, but even if I don't remember much about standard deviation and how that works and all that stuff, there's two answers that I'm going to eliminate. They don't make sense. They don't make sense even if I don't know much about standard deviations and means and margin of error and accuracy. 37 seconds. There's two answers that don't make sense. I want you right now for practice to eliminate exactly two answers. Or three, if you know which one's wrong. But minimum exactly two. In fact, if you eliminate three answers, I want you to also tell me, or in your mind, know which two I said are the obviously incorrect answers. And let's talk about the word obviously in a second. 4. Now, I know that sometimes students hear the word obviously incorrect and they say, oh, well, obviously incorrect. So what happens if I don't see it? Well, when I say obviously, I mean based on the logic of the problem and or some content, some piece of the content that makes it clear that that's not the answer. You just may have not seen the thing that makes it clear. However, so if you didn't see it, well, you made your effort to eliminate the two answers that I said are supposedly obviously incorrect. If you made your effort, great. If you didn't make the effort because you wanted to exit responsibility or exit the possibility of being wrong, whatever, that I recommend not. But here's the other thing that I've seen students do. They actually have a suspicion of which ones I say are obviously wrong, but because they insert doubt into the problem, they actually arrive at a point where they know that two answers are wrong, but they leave them in there just in case. Or vice versa, they know two answers are wrong, but they choose one of them anyway. Or they might say, I think choice 2 is wrong, but I'm going to pick choice 2. Oh, or I think choice 3 is wrong, but I'm going to pick choice 3. Or I think choice 4, or whatever it is. I think choice blank is wrong, but I'm going to pick choice blank. I've seen it happen so many times with my tutoring students. So which ones do I know are wrong? Which ones do I know are wrong? Well, let's see. Smaller sample size results in a smaller margin of error and should provide more accurate. So here's the thing, a smaller margin of error should provide a more accurate estimate. Bigger margin of error should provide a less accurate estimate. So choice 2 says a smaller sample size results in a bigger margin of error, bigger error, and should provide a more accurate estimate. A bigger margin of error can't provide a better estimate, a more accurate estimate. It can only provide a less accurate estimate. So that one is wrong. And the choice 4 also, a bigger margin of error should provide a more accurate estimate. Those are the two that I said are obviously wrong. There is another one that's wrong for different reasons, but if you chose those two as the ones that I said are obviously wrong, then you are in my head right now, which is good. So now the question is choice 1 or choice 3 wrong or right? It's choice 1 says that the smaller sample size of 5 teens results in a smaller margin of error and should provide a more accurate estimate. Or the larger sample size of 50 teens results in a smaller margin of error and should provide a more accurate estimate. As a rule, in stats, and why statisticians are paid a lot of money, more data, more accuracy. More data, more accuracy. You want to know if your shirt looks good? I think the shirt looks good. I designed it myself. Maybe I'll put a link to it in the chat after. I didn't think to put that, but I did design it myself. But if I ask one person if it looks nice, they're probably going to tell me yes. But if I want to know an honest answer about whether this design is nice, I probably got to ask more than one person. Okay, so more data, more accuracy. So probably this one is the more correct one. Larger sample size of 50 results in a smaller margin of error and produces more accurate estimate. So if you notice, for the larger sample size, I get a standard deviation of 0.057 whereas this one has a standard deviation of 0.2. This one's larger, and this one's smaller. The larger sample actually does provide a smaller margin of error. So it's definitely this one, okay? All right, número 19, number 18. And I put this box over here. If you feel like I've earned your subscription, please do subscribe to the channel. It only helps me, and I really would appreciate that. But that said, given f of x equals x cubed minus 3, and f inverse of x equals the cubed root of x minus 3b, the value of b is 1, -1, 3, -3. This one can be done by plugging in and checking. If you know how to do it that way, please do it that way. And you got a minute to try it out. And if you happen to know how to do it in another way, then I recommend, like if you know how to do it from first principles, then I recommend doing it that way. I am going to go get my random number generator out to choose one of the random choices and plug it in and see if I got it right. 25 seconds. Okay, that's my minute. That's your minute. I hope that you stuck to an answer. In that minute, I really want you to stick to an answer, because if, I mean, the same reasons I've been saying, like you could really fool yourself into thinking that you got it right, because in your mind you're like, I'm going to choose choice 2, but I think it's choice 3, or I'm going to pick choice 2, but I think it's choice 1, or I think I'm going to pick choice 1, but I think it's choice 4, and then I say, oh, this one's wrong. It's like I knew it was this one, or this one's right. I knew it was that one. I've seen students do it all the time, tricking themselves into believing that they know an answer is wrong. So, or an answer is right, or an answer is wrong. Okay. So there are reasons that there are 3 problems. There are 3 choices that I happen to be able to eliminate. Like I know that a cubed root is going to give me uh there's if I put in a 3 or a -3 into this problem, there's no way to actually get a 9 out of anything. So this one I suspect that these are going to be wrong. And there's another reason why I would eliminate the positive ones. I know that in the process of solving for the inverse function, I'm going to end up adding 3 to both sides. So you're going to get a plus inside. The only way to get a plus is by multiplying the -3 by a negative number. So I'm already down to, by just process of elimination, I'm down to the answer. I put the x's next to them when I actually gave you reason. I gave you suspicions why -3 and 3 were the wrong answer, but I also stated reasons why the positive answers were going to be the wrong answer. So that's really what my answer looks like right now. Crossed out 1 and 3, and I think, fake student me thinks that choice 4 is wrong. And in fact, real tutor me knows that choice 4 is wrong. But how do we actually do this one on paper? First off, how do we do it on by plugging in? So I know that if I plug in a number, this f of 0 is going to be equal to 0 cubed minus 3, which is equal to -3. That means that f inverse of -3 has to be 0. And if I test choice 4, test b equals -3, I could actually test it. F inverse of -3 should be equal to 0, but is equal to the cubed root of -3 minus 3 times -3. So this is the value of x. This is the value of x, and this is the value of b. Let's just be clear. That's just a lot of -3s, and this -3 was in the problem. That's where all the negative 3's came from. And of course, the cubed root, that's also in the problem. Okay, so let's see if this is equal to 0. Cubed root of negative 3 plus 9 is equal to the cubed root of 6, which is definitely not equal to 0. So choice 4 is incorrect. So now choice 2 is the answer, but how do I actually confirm it? So how do I actually calculate it? I do this. I say y is equal to x cubed minus 3. I switch the x and the y. And then step 2 is I solve for y. So I switch the x and the y. I get x equals y cubed minus 3. And now I solve for y. Plus 3 plus 3. I got y cubed equals x plus 3. Cubed root to get rid of the cube power. I got y is equal to the cubed root of x plus 3. So that is the cubed root. So now if you look at the answer, this one has x minus 3b, and this one has an x plus 3. That means that negative 3b equals 3 divided by negative 3, divided by negative 3. I get that b is equal to negative 1. And that confirms that choice 2 is the correct answer. Okay? I gave you a lot of different ways of doing this problem. So if you feel like that's worth a subscribe, please do. And I really appreciate it. I know that a lot of YouTubers, by the way, are like, subscribe, subscribe, subscribe. But the thing is that the way that I gain a benefit, remember that I talked about why I'm doing this for free, but the way that I gain a benefit is by you subscribing. So that's the only way that I gain a benefit. So I would appreciate that. That said, numero 20, number 20, Robert is buying a car that costs $22,000. Okay, that's a good car. After a down payment of $4,000, he borrows the remainder from a bank. A 6-year loan at 6.24% annual interest rate. The following formula can be used to calculate his monthly loan payment. R is equal to P times I times 1 minus parentheses 1 plus I to the power of negative T. It's an overwhelming formula, I agree, but they tell you what the letters mean, and they're not actually expecting you to do a ton of algebra with it. R is your monthly payment. P is your loan amount. I is your monthly interest rate. And T is your time in months. Robert's monthly payment will be, is it $298.31 or $336 or $307.35 or $367.10? One of those answers is not like the others, so either it's definitely wrong or it's more likely to be right, right? All by itself. And sometimes that's enough to be able to eliminate the other 3 choices and be left with just one, or that's enough to eliminate just that one choice and be left with 3 choices, which actually is equivalent to a passing question, right? It's equivalent down to 1, down to 3, on average is down to 2. That's actually it's more than equivalent to a passing question. It's actually worth more than that, in a weird way. So 44 seconds. If you don't know how to do this problem, I mean, this is what I'm telling you. Find some numbers to plug in. They tell you what R, P, little I, and T stand for. Plug in some numbers. And do what you can. Okay? Five more seconds. Let me snooze this alarm again. There we go. Okay. So when I was doing this problem, I started thinking, I'm like, I think for me, this was one of the harder problems to do my process of elimination for. I don't know why. My intuition broke on it a little bit because I know that the loan amount, well, if he's buying a car that costs $22,000, but he put a down payment of $4,000, meaning he took $4,000 out of his pocket, paid for the car, that cost $22,000, he needed to borrow $18,000. So the loan payment is equal to 22,000 minus 4,000 equals 18,000. And he's paying for this for 6 years. And they want to know the monthly payment. So 6 years, 6 times 12 is equal to 72 months. Okay? So if I did 18,000 divided by 72 to get a lower bound. And I did 18,000 divided by 72. And then this is equal to exactly 250. Now, the reason this broke my intuition was because a lot of times that lower bound is one of the answers, but it's not one of the answers. And this time it actually ended up being pretty far from the answers. And real teacher me knows that the 6.24% for 6 years can't make the answer too big, which allowed me personally to eliminate a choice. But I started thinking about how a student like you might be able to eliminate a choice, and this is an upper bound. I would do an upper bound of 250 times 1.0624 to the power of 6. This is a very big upper bound. And when I'm doing this, I'm saying hopefully maybe it eliminates more than one choice. But in this case, 250, 1.0624 to the power of 6. Now, a lot of teachers, by the way, wouldn't appreciate me showing this, but the truth is, or this way, but the truth is it's good, just like it's good to teach the controversy, it's good to teach the thing that students do to get things wrong, because sometimes that answer, fixing the incorrect method or acknowledging the incorrect method as being actually useful in another way may actually increase intuition for students. And in this case, the upper bound is equal to 359.474741. That eliminates choice 4. That eliminates choice 4. Because 367 is above the upper bound. Okay? Okay. That said, I think that a lot of students will get this one wrong because there's some details that they're not applying correctly. So let's actually talk about how to actually do the problem. The I is the monthly interest rate. The yearly interest rate is 6.24%. If you assume that the monthly interest rate is that divided by 12, does it say compounded monthly? It usually is compounded monthly when you do a loan. So after all, you're making payments every month. So if you do 6.24 divided by 12, you get 0.52%. Okay? Also known as 0.0052. Okay? And then the time t in months is equal to 72. So this is another place that students get it wrong. They do the time in 6 years, but they told you that it's time in months. Okay? And so this is the only variable, these are the only variables that you can calculate directly, and then they want the monthly payment. So this is actually just a plug in and chug. That's it. So R is equal to PI. So P is 18,000. I is 0.0052 divided by, now I'm going to put parentheses around the entire denominator. So this is the third place where students get messed up. They forget to put parentheses around the entire denominator. The horizontal fraction bar is a grouping symbol, but the diagonal fraction bar on your calculator is not. So you do need parentheses. So 1 minus parentheses 1 plus 0.0052. the power of negative 72. And so we literally put this into our calculator. So let's see, 18,000. And a lot of teachers actually teach putting parentheses around the entire numerator. So I'm going to honor those teachers by putting parentheses around the entire numerator. 0.0052, close parentheses, close the numerator, divided by, open the parentheses for the denominator, 1 minus, another parenthesis, 1 plus 0.0052, close parentheses, to the power of negative 72. Close the denominator, enter, get 300.355. Okay, now I'm going to mention something that I do. I've modified how I teach it for the Regents prep. So, and I'm going to teach it to you now because it's going to become relevant perhaps in a few minutes. I'm not trying to recall how often it becomes relevant. So R equals 300.3554442. So my new strategy is to write the entire thing. And if you think that that takes a really long time, if you timed how long it took me, less than 2 seconds. And then I look to round to the right amount, and this is to the nearest penny. So R is equal to 300.3, and then 5, the 5 goes up. So this one goes up. So 6, 300.36. And that is, by the way, how they calculate final loan payment, by the way. They actually round up your first 71 loan payments, and then your 72nd loan payment ends up being like pennies less. But I said pennies less, but that's actually a lie. It's actually, it often is dollars less. That tiny fraction of a penny not gaining interest actually adds up to dollars often in the end. And in this case, you're literally rounding half a penny up times 71 weeks. That's 36 cents. You would think those 36 cents gaining interest doesn't have a significant amount, but it can. And in this case, I don't know how much it'll be. Maybe like 60, 70 cents. Okay. And by the way, that's a lesson for you. Saving a penny here and there actually adds up to dollars in the end. So numero 21, number 21, given that tan theta equals negative 4/3, where pi over 2 is less than theta less than pi, what is the value of secant theta? There's a lot of ways to do this problem, including the calculator. So I said that there's often 10 to 20 different ways of doing this problem. There's so many trig identities. We've got 55 seconds left. There's so many trig identities. There might be actual hundreds to thousands of ways at this level of doing this problem. Hundreds to thousands of ways of doing this problem. So, secant theta. Negative 5/3, negative 3/5, 4/5, or 5/3. I already got some eliminated answers. $18 seconds. Like, I almost don't want to tell you, but you got a calculator. You know, you got a calculator. You got ASTC. You could draw a diagram. You got your special right triangles, Pythagorean triples. Okay. So I've seen a lot of students do this one with a calculator. They literally find the angle, and then from that angle, they get the secant of the angle, and one of these answers matches that. So I will say this, that secant theta is, well, actually, cos theta is between -1 and 1. That implies that absolute of secant theta. So remember that secant theta is equal to 1 over cos theta. Well, if cos theta is between -1 and 1 inclusive, that means that secant theta in absolute value is greater than or equal to 1. In other words, secant theta is less than or equal to -1, or it's greater than or equal to +1. That eliminates choice 3 and choice 2. And like, there's already a way to eliminate choice 1 or 4. One of those is eliminable. Like, look at the quadrant. ASTC, right? ASTC. In the second quadrant, sine of theta is greater than 0. And 1 over sine theta, which is cosecant of theta, is greater than 0. And the other ones are going to be negative. So the answer is going to be negative. This one's positive, right? That's confirmed wrong. I've already, just by process of elimination, confirmed that choice 1 has to be the answer. And I didn't even do the problem. But I promised that I would always do the problem. So and I'm in the second quadrant here, okay? So I got -4 over 3. So 4 and -3. And by the Pythagorean theorem, this hypotenuse is equal to 5. And here's my theta. So cos theta is equal to adjacent leg over hypotenuse, which is equal to -3 over 5. So secant theta is equal to 1 over cos theta. So the reciprocal of -3 over 5 is equal to -5. Choice 1. Groovy. So many different ways of doing this problem. You could have plugged into your calculator. Let's just make sure that we know how to do tan inverse. Tan is right there. Tan inverse of, let's see, the ratio is -4 over 3. I got to make sure I'm in radian mode. Okay. I get an angle that's less than 0. But if I add pi, I'm now greater than 0. I'm between pi over 2 and 2 pi. Okay. So I got my angle, and I could do cosine of that angle. And I get 1 over the answer. And I can convert that to a fraction. Math, the very first option, arrow frac, convert to fraction, -5 over 3. Groovy. Número 22, number 22, to solve the equation 7 over x plus 7 plus 4x over x minus 7 equals 3x plus 7 over x minus 7. And Jones' first step is to multiply both sides by the least common denominator. Which statement is true? Is -14 an extraneous solution? Or is 7 and -7? Are they extraneous solutions? Or is 7 the only extraneous solution? Or there are no extraneous solutions. By the way, choice 3 says 7 is an extraneous solution. Choice 2 says 7 and -7 is an extraneous solution. I added the statement, is 7 the only extraneous solution? That's not correct. That's not what it says. It just says 7 is an extraneous solution. However, that's what it says. Choice 4 is there are no extraneous solutions. This one, I'm giving you the minute. There are ways of shortening the problem. I promised that I would do this problem on paper. But I'm also gonna just express how to shorten it. And there is an answer, one answer that I would eliminate right away. One answer that I would eliminate right away. May or may not be the answer that you think, but see if you can eliminate an answer. 30 more seconds. You kind of have to know what an extraneous solution is. And if you've had extraneous solutions in math class, you kind of have some intuition on what they are. 15 seconds. To my current concurrent viewers, I see that we have 3 current viewers right now. Thank you for being here. We've had 24 total viewers. I appreciate your being here. And I know you could do really well on the test tomorrow, so I appreciate your being here. So about this, why I was able to eliminate an answer. An answer is an extraneous solution if the algebra tells you that it's a solution, but it turns out after the fact that that particular answer, perhaps there's no way for that answer to be a solution, but it would have to violate something in the problem. in this case, the only thing that could be violated is dividing by 0. There's nothing else that's illegal. There's no radicals. There's no sines, cosine. There's no trig. There's nothing illegal other than possibly dividing by 0. You can't divide by 0 by plugging in a 14, which means that 14, at the beginning, 14 cannot be an extraneous solution. Even if it is a solution, it can't be extraneous. So that now I'm down to a 1 in 3 chance of getting it right. That might not seem valuable, but that's points on the Regents. That is points on the Regents. So either 7 and -7 are extraneous solutions, or 7 is an extraneous solution, or there aren't any extraneous solutions. In fact, the only possible extraneous solutions are dividing by 0. So -7 and 7 are in theory possibly extraneous solutions, but we'd have to do the algebra to get the answer. So how do we do the algebra? We multiply by x plus 7 times x minus 7, because that's the multiplying both sides to get the least common denominator. Multiply this by x plus 7, x minus 7, and then multiply this by x plus 7, x minus 7. And if you notice here, the first term, the x plus 7 cancels. The second term, the x minus 7 cancels. And the third term, the x minus 7 cancels. Okay. Okay, so that gives us the equation 7 times x minus 7 plus 4x times x plus 7 equals 3x plus 7 times x plus 7. Now, this is enough to plug into your calculator. You could graph the left side, graph the right side, or go into the table with the left side and the right side and see what the solutions to the equation are. And then when you see the equations, the solutions, you do get -14 is a solution, but it can't be extraneous. So it turns out that one of these numbers happens to be extraneous, okay? And there are reasons to realize that -7 can't be an extraneous solution, because if you plug in real quick, -7 isn't a solution. I'm sorry, that yeah, -7 isn't a solution at all. So that's a hint that that's already and so -7 is not a solution. Before even doing the distributive property, you got a 0 on the right side, you got a 0 as the second term, and you got a non-zero number as the third term. So you got a non-zero number plus a 0 equals 0. That's never the case. So this has to be the wrong answer. So if there is an extraneous solution, it's gonna be 7. So I promised that, again, you could do this on the calculator by scrolling up and down, but I promised by plugging this as function like y5 and this as function y6, and then scrolling up and down till you find where they match, okay? And then, because then if 7 is a solution, then it's extraneous, okay? But I promised that I would do this on paper, because on part 2s, 3s, and 4s, they could ask you to do this on paper. So 7x minus 49 plus 4x squared plus 28x equals, now we have to do the FOIL or each with each. Big fan of the box method, which matches each with each, by the way. 3x and 7 and x and 7, 3x squared, 7x, 21x, and 49. And now we could combine like terms from here. So 3x squared plus 28x plus 49, okay? Subtract 3x squared, subtract 3x squared. And in fact, I could just subtract the 28x now, 28x, subtract 28x, subtract the 49, might as well subtract the 49 now too. And now I'm gonna be careful here. So I got 7x minus 49 minus 49, minus 98. And then plus x squared, plus 4x squared minus 3x squared, plus x squared. And then that cancels. And that's equal to, all of these just canceled. I canceled them out, so that's 0. Rearrange in the correct order. That's x squared plus 7x minus 98 equals 0. Okay, now this one factors, since I know that the solutions are either integers or not, I could actually start with what might be the answer. So if 7 is an extraneous solution, that would mean that 7 is a solution to this equation, which means that -7 would be one of the numbers that add to this. And then, in fact, if I put a 14 here, -7 plus 14 is 7, and -7 times 14 is -98. So this factors as x minus 7 times x plus 14 equals 0. I got that x minus 7 equals 0, x plus 14 equals 0, minus 14. I confirm that x equals -14 is a solution. And then plus 7 plus 7. I confirm that x equals 7 is possibly a solution. The reason it's extraneous is that this results in a division by 0. In the original equation. So 7 is an extraneous solution. And so the choice 4 is wrong. I promised that I would do it completely. Again, because I've shown you already how you could do the problem on the calculator. And it's really important that we kind of do both so that you get an experience with both. Okay? I'll do this one completely on the calculator just to show you the benefit. Beginning July 1st, 2019, Michelle deposited $250 into an account that yields 0.15% each month. She continued to make 250 deposits into the account on the first of each month for 3 years, which expression represents the amount of money that was in the account after her last deposit was made on June 1st, 2022. So this is a bit of a long slog. I'm going to give you the minute to do the problem. This one, if you just plug it into the calculator, you might find that you could eliminate answers very quickly. I will give you this hint. There's 2 types of problems that they give you in terms of depositing or payment. In the past, the Regents, for some reason, has really been obsessed with like making a single deposit and never depositing anything ever again, which isn't matching real life. In this problem, though, they did more what matches real life. You bought a car, you have to make payments every single month of the same amount. Or when people invest, often, and this includes me, when I invest into my retirement account, I actually do deposit the same exact amount into my account each month. That's a hint. 7 seconds. All right. So, process of elimination. Michelle deposited $250 into the account every single month for 3 years. So, and it's gaining interest. So there's a lower bound of 250 for the final balance times 3 years times 12 months in each year. Well, let's find out what this number is. And by the way, this is a lot of how a lot of retirement accounts actually grow. A certain amount every month, okay? So let's find out. 250 times 12 times 3 times 12 or times 36, whichever you prefer. $9,000. So the answer, that's a lower bound of $9,000. Okay? And the actual answer is going to be bigger. This is the reason it's a lower bound. The lower bound is generated by not factoring in the interest. Is there a benefit in doing this way? Obviously, there's a benefit. Like, look, let's actually test this. So this is saying which expression represents the amount of money that was in the account after her last deposit was made. Now, this one I'm not going to do the random number generator to choose because I'm actually going to plug in all of them. And I'm going to go in order from 1 to 2 to 3 to 4. Okay, let's put that here. choice 1, 250 times 1.0015 to the power of 3. 251, not 9,000, not even close. All right, definitely need a bigger thing. How about 36? And notice, by the way, what I just did. Okay, let me just clear this. I scrolled up to the previous thing that I typed and pressed enter. It typed everything for me. That's a benefit because sometimes you only have like one little character to change. This to 36. Enter. 263, still not 9,000. Okay, so now you may say, well, this one's really hard to type in, but in fact, these two look the same. So if I type one of them, then I could just modify the other one to type the fourth one. So let's do that. I put parentheses in the numerator and denominator because I need them. 250 minus 250. Let me erase the stray mark over here. Time minus 250 times parentheses 1.0015 close to the power of 3 divided by 1 minus 1.0015. Let's see if this is around 9,000 or a little bit bigger than 9,000. Nope, 751. This is what I would get if I just deposited money for 3 months. Instead of 750, my money gained interest about $1.13. That's what I would get in 3 months. But now, final answer, the only thing that changes is the exponent here, 36. For 36 months, you get 9,240. Let's get that over here. 9,240. These are not even close to the correct answer. Okay? How did we possibly do this? I mean, this is literally how did we do this on paper? Because I promised I would do this on paper. I'm going to erase that for a second because somehow the moment I circle things, students start to skip. So the first 250 gains interest at 0.15% monthly for how long? 3 years. But they said the deposit was made on June 1st. On June 1st, that's actually the 71st month. So 71. Plus the next 250, 1.0015 gains that interest for 70 months. Plus the next 250, 1.0015 to the 69 plus ... Thank you, Jelly. Jelly is, by the way, say hi, Jelly. Jelly is the moderator for the chat. I see someone asked if we're going over the whole test. William asked if we're going over the whole test. Yes, we are. Thank you, Jelly. Plus ... Jelly is my fiance. I'm peanut butter. We go great together. Plus ... Plus the second to last deposit is gonna gain 0.15% interest for just 1 month, and then the last deposit is not going to gain any at all. Okay, not for that 1 month. It's going to gain for another month, but they said June 1st. We're going to stop on June 1st, 2022, after starting on July 1st, 2021. And if you notice, this is actually a geometric sequence, and in fact, it's a geometric series. So if we go to the formula sheet, close that, go to the formula sheet, there is a formula for a geometric sequence and another one for geometric series. And there's our geometric series formula. So what is a geometric series? Well, a geometric series is taking the elements of a geometric sequence and adding them. And how is this a geometric sequence? Well, a geometric sequence is gotten by multiplying previous terms by a single number. Okay? But repeatedly, over and over, by the same number over and over, and that number is called the common difference R. So here, A1 is equal to 250, and then R is equal to 1.0015, and then N is equal to the number of the last power, 71. No, sorry, n is equal to the number of terms. Which is equal to 72. So Sn is equal to A1, 250, minus 250, according to the formula, the R, 1.0015, to the power of 72, all of that divided by 1 minus R. 1 minus R, 1.00. And actually, we don't even have to calculate it anymore because that is the answer as written. Groovy. Nice, right? And we did it by plugging into the calculator. I think that's phenomenal. Super duper. So number 24, numero 24, a study of the red-tailed hawk population in a given area shows the population h of t can be represented by the function h of t equals 50 times 1.19 to the t, where t represents the number of years since the study began. In terms of the monthly rate of growth, the population can be best approximated by the function h of t equals 50 times 1.015 to the 12t. They've been liking the 1.015 in this test. Or the 1.0015, I've noticed. Or h of t equals 50 times 1.15 to the t over 12. That's just coincidence. Or h of t equals 50 times 1.19 to the 12t, or h of t equals 50 times 1.19 to the t over 12. Let's take the minute. But do remember, t represents the number of years. A lot of students get this one wrong because they just reinterpret t to represent the number of months. One of the reasons we introduced this function notation, h of x, h of t, f of x, is that variables really are supposed to represent a single thing. And before introducing function notation, variables sometimes represented more than one thing. T represents the number of years, not the number of months. In the answer choices, t still represents the number of years. So sometimes we have to bring in, somehow we have to bring in the monthly growth rate. That is my hint. T has to represent the number of years. What does h of t have to represent? 15 seconds. Move my legs around. Okay. I said that as a hint. It was a hint that t has to represent the number of years in the beginning and in the answers. How can we apply that hint? Well, h of t represents the population of the red-tailed hawk, which, by the way, this is an exponential growing function, which is great. Great news for the red-tailed hawk. But the thing is that h of t has to also represent the population of red-tailed hawks in the answer choices. So h of t in the answer choices and h of t in the problem have to be the same number. So how do we do this problem? There's two ways of interpreting the problem, and they're close to each other, but there's one more correct way. And I'll give both ways because I'm debating. Okay, so 1.19 is equal to the yearly growth. So 1 plus 0.19 is equal to the yearly growth. So that implies that 0.19 is equal to the yearly growth rate. Okay? So what about the monthly growth rate? The monthly growth rate is approximately 0.19 over 12. And that actually can lead us very close to the correct answer. But if you do 0.19 over 12 on the calculator, you get 0.0158 3333 repeating. And in fact, I could actually change that to an equal sign because that's it. But notice this rounds to 0.016, which is like, why do they have 0.015? The actual monthly growth rate. So the monthly growth is actually equal to the 1.19 to the power of 1 over 12. In other words, 1/12 of 1 year, which is approximately 1.19 the power of 1 over 12. I'm going to put this over here just so we have it. 1.04160167687. 687. Okay, I got to write a little bit smaller to get all that because there's a reason I'm doing it. 0.1460167, which is rounds to the correct point, 1.015. That's a hint that this one might be incorrect, that this one might be incorrect, and that this one might be incorrect, and that actually choice 1 is the only answer that makes sense. Okay, so where does choice 2 make sense? Not putting the 0. That's where choice 2 comes in. In fact, if you actually put all of these into the calculator, this is another one that if you put this into the calculator, I'm gonna put the answer. Well, we're down to choice 1, right? And I'm going to put one of the other ones in the calculator. So the original one is 50 times 1.19 to the power of x. And the next one is 50, the choice 1, 1.015 the power of 12x. So we're going to talk about where that 12 comes from in a second. And the choice 2 is 50, just to choose one, 1.15 to the power of x over 12. So if we go to the table and scroll, y5 is the original, y6 is the correct answer, y7 is one of the incorrect answers. And you see that these are actually fairly close to each other. And it might be frustrating because you might be saying these aren't that close to each other. And you would be right because of the rounding. It's important to know that this is a problem that they will always give on the Regents. And so we do need to be able to know how to do this problem. Okay, so we again the monthly growth rate is equal to 1 plus r, where r is the yearly growth rate, to the power of 1 over 12, and then the exponents is equal to the number of months. Well, if that's 12 times the number of years, which is equal to 12t. And so that's where the answer, choice 1, comes from. So h of t equals the original population, 50, times 1.015, the monthly growth, the power of 12t. And if you did plug in choice 3 and choice 4 into the answers, you would see choice 3 blows up way too fast, and choice 4 barely grows at all. Okay? So choice 1 is the only answer. And before we go to problem 25, which is a part 2 problem, I just want to point out, this is what all my problems look like. Do you see how much writing I've done? Many of these problems have exactly as much writing as you should have, like number 18. number 19 actually has about as much work as you might want to write. If you did it the red way, you would have all the red work. But if you did it the blue way, you would have all the blue work. Okay? So this is actually not an unreasonable amount of writing. And yes, I took longer than 3 hours to do this, but I'm doing a lot of exposition. I'm doing a lot of exposition. You would be able to do this quicker than I can. And if you don't believe that you would be able to do this quicker than I am, then do understand that when I do my video editing, that 1 minute practice is cut off. Any place where I maybe misspoke, I might cut it off. Any place where I said the word and I would cut that off. Any place where I'm speaking before writing, I would cut that off, and I would actually speed up a little bit of something here and there to make the video more efficient. But I take about 3 hours to do all of that exposition. If I could do that in 3 hours, that means that you could do it in 3 hours. So it actually, you should be doing all that writing on the part ones. And here's the big reason. This is where I get to talk about showing work. A lot of teachers have given up on making you show work because students just refuse and refuse and refuse to show work. And what happens when they get to the part 2s, 3s, and 4s is they don't show work. And so they don't get it right. And they don't get any partial credit either. But the thing is that if you really want to master the part 1s, you have to show work. But if you show work on the part 1s, then you can master the part 2s, 3s, and 4s. And why I know that, yes, I only look at a finite number of tests, and I see that most of those tests have blank part 1s with no work. Why I know that that's actually true about the majority of tests across the entire state and the entire country is this. If you show work on the part 1s, then you show the same work on the part 2s, 3s, and 4s, you're going to get partial credit. And very often, you're just going to find that you actually get full credit. Which means that if you're a student who just barely can eke out a 65, which is a passing grade on this Regents, then you should be able to eke out an 80. So there actually should be, in the statistics, a lot of students not quite getting to a 65, maybe some getting to a 65, and then the students who actually work towards a 65 show work on the part 1s, and therefore on the part 2s, 3s, and 4s, there should be a gap in grades where almost nobody gets a 65 to an 80, and then a bunch of students get 80 and above. Because that gap doesn't exist, I know that the students aren't showing work. And so that's the reason why a lot of students are getting the grades that they really, lower than they really deserve. So my advice, show work on the part 1s. You will be able to master the part 2s, 3s, and 4s. Part 2, we know that part 2s are worth 2 points. The big thing, again, I always point out, although on this test, this is just such a weird test, diagrams are not necessarily drawn to scale. Again, almost every diagram on almost every test is drawn to scale. Most tests have 0 diagrams not drawn to scale. Some tests have 1 not drawn to scale. Occasionally, I've seen 3 or 4 tests with 2 diagrams not drawn to scale. I still have not seen a test with 3 diagrams not drawn to scale. With maybe sometimes 15 to 20 diagrams in a test, that's a significant statement. So what that means is that if you get to a question and you don't know how to do it, but assuming it's drawn to scale will help you get the right answer, or get an answer, assume it's drawn to scale. Or even better, check and confirm whether it's drawn to scale. And once you confirm that it's drawn to scale, then get the right answer. That said, this test is weird. It just doesn't have any diagrams that are even capable of not being drawn to scale. I've never seen that in my life, which is weird. Okay, so numero 25, number 25, I'm going to give you the minute. Factor this x cubed plus 4x squared minus 9x minus 36 completely. I'm going to give you the minute. Getting a calculator out can absolutely help you. I'm gonna, while you're working, I'm gonna start typing this into my calculator. 30 more seconds. 7 seconds. All right, and I've typed this into my calculator. The reason I typed it into my calculator is that factors and roots correspond to each other. That's actually one of the big reasons why we teach it a factor. Why do we care about the roots of polynomials, by the way? It just turns out that that's the thing that we care about in real life problems. In math problems in fake life, I call math class fake life, but also real life problems in life. We literally turn it into finding the zeros. And how do we turn it into finding the zeros? Well, we have an expression and we have another expression. We know that they're equal to each other. Take one side of the expression, subtract it away so that you have something equal to 0. And now you're looking for roots. So that's why even in real life, we care about the zeros. If I graph this, I'm going to do zoom standard again, get this back to reset. Okay. I see that it has a root around -4, a root around -3, and a root around 3. That tells me that this polynomial, if it factors over the real numbers, it's going to factor with 3 distinct roots. And it does look like the roots are -3 and 3. So I'm going to go to my table and -4. So I'm going to go to my table. I confirm that -3 is a root, or that +3 is a root. I confirm that -3 is a root. And I confirm that -4 is a root. So I've actually confirmed that my final answer. So it's going to look like this: -4, -3, and 3. I confirmed that the answer is going to be x plus 4, x plus 3, x minus 3, or some scrambling of those factors. I confirmed that using the calculator. So now that I confirmed that, if I show some work and get the answer, then I get the points. Then I get the points for it. Notice I just turned this into a problem that students often skip into a problem that's 2 points. 2 points is what the multiple choice questions are worth. If you get 2 points here, you got a free multiple choice question. If you get 1 point here, this is where it's important. Multiple choice, why I recommend not just focusing on the part 1s, because multiple choice questions are either right or they're wrong. You get 2 points or 0. Whereas the part 2s, 3s, and 4s, you could get 2, 1, or 0. The part 2s, you can get 2, 1, or 0. Part 3s, you can get 4, 3, 2, 1, or 0. Part 4s, you can get 6, 5, 4, 3, 2, 1, or 0. That's a lot of points, a lot of free points that a lot of students are giving up. So if you do some part of the factorization and then just give this answer, it turns out that's enough to often convince the grader that you did it right. So how am I going to do this? I noticed that I can actually factor this by grouping. So the first 2 terms have a common factor of x squared, so I get x squared, factor a pair of x plus 4. And then if I factor out a -9 from the second 2 terms, the third and fourth term, I get a -9 with a factor pair of x plus 4. That means that I have a factor of x plus 4 with a factor pair by the distributive property of x squared minus 9. And now x squared minus 9 is a difference of 2 squares. I know that p squared minus q squared is equal to p plus q, p minus q, where p is equal to x and q is equal to 3. So x squared minus 3 squared. So I got that this is x plus 3, x minus 3. That's a squiggly 3 times x plus 4. And that's my factorization. Finished. 2 points. If at any point you stop halfway through, that's a point. That's a point. So that's a lot of points on your grade. If your worry is passing, you have to focus on the part 2s, 3s, and 4s. If you know you're going to pass, but your focus is getting an 80, well, you have to focus on the part 2s, 3s, and 4s. And if your goal is not to get into the 80s, but get into the 90s, or maybe even that really golden 100, then you really got to focus on the part 2s, 3s, and 4s, because you can't get 100 without doing the part 2s, 3s, and 4s. So there is no point in any grade level, at any score level, at any goal level, where not focusing on the part 2s, 3s, and 4s makes sense. Number 26. Determine if x plus 4 is a factor of 2x cubed plus 10x squared minus plus 4x minus 16. I'm going to give you the minute. And it says determine and explain. You have to use words. Justify means you could just use plain numbers without words. Explain means you have to use words. "43 seconds. Think about now how to get full credit. You may find if you just do anything in the correct direction, it may be worth a point. Make sure to get to a final answer. That is one of the rules for getting your maximizing your score. Do get to a final answer. It asks if x plus 4 is a factor. You have to get to the point where you say either yes or no, it's not a factor. But that said, if you make a mistake, you might still get partial credit. If you say no when it's yes, if you say yes when it's no, you might still get partial credit. But you also have to use words. Okay, so I see that there's a lot of different ways of doing this problem. One is, for example, factoring this original polynomial. There is a factor by grouping that can be done, but when you get to cubics, factor by grouping can be more difficult if, for example, the x plus 4, for example, is not a factor of the first two terms and the second two terms. Like sometimes the factor by grouping is split into a quadratic and another quadratic. And that specifically is in the situation where you don't have a difference of two squares, but that's on the teacher side more than on the student side. In this case, on the student side, what's relevant is you can't just count on factor by grouping the first two terms and the second two terms to determine whether the x plus 4 is a factor. But I know that x plus 4 is a factor if and only if x equals -4 is a root. So what I'm going to do is I'm going to determine if x equals -4 is a root. Okay, so I am going to divide by x plus 4 using synthetic division. 2, 10, 4, -16. So cube squared first 0. There's 4 terms. No skipped terms with a 0. Good. There. Put the -4, put the root outside. That's where the remainder is going to go. Bring that down to 2. 2 times -4 is -8. -8 plus 10 is 2. 2 times -4 is -8. -8 plus 4 is -4. -4 times -4 is +16. Remainder 0. Okay? So I have that x plus 4 is a factor of 2x cubed plus 10x squared plus 4x minus 16 because -4 is a root of 2x cubed plus 10x squared plus 4x minus 16. Equivalently, you may at this point decide to write that, so this would be a 2-point answer, but you may equivalently, after showing the work, you may instead decide to write x plus 4 is a factor because when dividing by x plus 4, the remainder is 0. There's our remainder, okay? The remainder is 0. That's also, after that work, that's also a 2-point question. If you just do the synthetic division without saying any words, that's a point. In fact, the truth is, so this is where we got to be careful because it's going to depend on the grader. But if you write the first sentence and then write the synthetic division, will they interpret the first sentence as the explanation? I don't know. I might not. So it's not a safe assumption. I gave an explanation. That is the safer way to go about it. Okay? Número 27, number 27. An initial investment of 1,000 reaches a value v of t. According to the model, v of t equals 1,000 times 1.01 to the 4t, where t is time in years. Determine the average rate of change to the nearest dollar per year of this investment from year 2 to year 7. And I'm going to start my timer. There is no process of elimination that we could do, but I'm gonna tell you an estimate that I make afterwards, or not after the work, but before. I'm gonna write my little estimate here. It's a question that a lot of students ask, and a lot of teachers ask, and a lot of tutors that I've trained ask. Do I actually give the estimate every time when I'm fake student me is doing the test, or in other words, do I recommend students actually write the estimate every time? I actually do. Especially during class time, I always actually request and often require it. Uh, when I say often required, I mean basically every time. Something that will confirm the answer. 9 seconds, and I'll explain why in a second. For the teacher, I'll explain why for the teacher, but I'll also explain why for the student. For the teacher, but especially for the student. This is especially for the student, but for the teacher, why do I have students make an estimate at the beginning, but every time they do the problem? And for students, why do I do it? It actually turns out that making an estimate is an intuition fixer, but it also serves as a check. And a lot of students refuse to do checking your answer by plugging in again or checking that the work is right. But the estimate is often just way faster than the check after the fact. And the thing is that the check after the fact can feel like a waste of time because you've already gotten the answer. Now you have to go back and do something else. But the estimate is usually often quick. So here is my estimate. I know that 1.01, this is 1,000 times 1.01 to the 4t, where t is time in years. 1.01 to the, well, 1.01 means that the 1% growth rate every quarter of a year, every 3 months. So that's a little more than 4% yearly. So more than 4% yearly. And so 1,000 times 1.04 is equal to 1,040. So my estimate is equal to 40. Notice that my estimate is equal to $40, but I can also say, since this is only for 2 years to 7 years, it's not like, 20 or 30 years. It's actually a bit more. So I got a lower bound on the average rate of change, and I could say that it's not like going to be like 1,000. It's not going to be it's not going to be like 500. It's not going to be 220. It's going to be a little more than 40. If this was something like 2 to 70 years, or 20 years to 30 years, 25 years to 35 years, then maybe 40 would be a great lower bound. It still is a great lower bound, but then you could say it's actually going to be a lot more than 40. And that actually is super helpful. So how do you get average rate of change? You do need to know this. That's equal to V final minus V initial divided by T final minus T initial. A lot of teachers, when I was growing up, they used to like writing it this way, delta V over delta T. Okay? So, and I better get something a little bit over 40. So let's see, I get 1,000. This is V of 7 minus V of 2 times 1.01 to the power of 4 times 7 minus 1,000 times 1.01 to the power of 4 times 2. And I'm actually going to, so first put that fraction bar right there. I'm actually going to put this in parentheses in honor of the teachers who would, but also in honor of the students because you have to. You actually need the parentheses when you put it into the calculator. And the denominator, 7 minus 2, parentheses. Why do I not need them in the paper? Well, because the horizontal fraction bar is a grouping symbol. It's called a vinculum. But the diagonal fraction bar is not a vinculum. It's not a grouping symbol. So the diagonal fraction bar requires you to put parentheses. And so I'm going to do this on the calculator. Now, do you have to simplify this on paper? You actually don't, okay? But this is the first time I get to tell you about what my simplification strategy is to make sure I round to the correct thing. I actually put the entire answer into my paper. So let's put that there. Parentheses, 1,000. Parentheses, 1.01, close parentheses, power, 4 times 7. Can I simplify that on paper? Yes. Should I? If you want. Since this is a calculator problem, you actually have to use the calculator. Might as well let the calculator do it. This is enough. You don't have to simplify further than that. Okay? Close parentheses, divided by parentheses, 7 minus 2. All right. Notice I put parentheses in the numerator. I have to. I put parentheses in the denominator. I have to. I get an answer. I got 47.68. And this is where I want to be clear of what I do on paper and on the test now. I put the full answer that I got on the calculator now. This is a change that I've made 25 years of tutoring, and this is something that I did now after all this time. I tell them to put the entire thing that the calculator says. And you could time me how long it takes me to write this. 68685225. Stop. 6 seconds to type all those decimals. Did I waste 6 seconds? No. Because here's the problem that a lot of students run into. They put whatever answer rounded to whatever they prefer or what they're used to rounding to in class. So they have muscle memory rounding to whatever they're used to rounding in class, and they forget to round to what they said. So now I say, don't round, put the entire answer in the calculator. Second step, underline what they tell you to round to, and then get that answer. 47.68, that's actually rounds up. 8. And that is my answer. Okay? So, step 1, write the whole answer. Write the calculator, answer fully. Step 2, underline their rounding requirements. And then step 3 is round correctly. In that order. I found that the thing is, fighting muscle memory is really difficult. This is for teachers and for you students. Fighting muscle memory is a really difficult thing to do. So I'm not going to do that. I'm not going to fight your muscle memory. Instead, I'm going to replace it with something that actually very naturally replaces muscle memory, which is writing the entire thing from the calculator, underlining the rounding requirements, their rounding requirements, and then round correctly. That tends to replace rounding muscle memories very well. Okay? That's this right here is a 2-point problem. Notice it says determine. That's it. So we've determined it. Okay. Número 28, number 28. And for anyone who's joining us now, by the way, I've been asked, am I doing the whole test? Yes, I am doing the whole test. Okay. So I'm on number 28. After I'm done with number 28, you can definitely go back and start with number 1. All the strategies that I gave you for guessing and checking, for plugging into the calculator, for how to do process of elimination, unique methods of process of elimination that work for you. You can go through those and why it's beneficial to show your work on even the part 1s. Let your teacher win that battle. Show work on the part 1s. Okay, número 28, number 28. When parentheses 1 over cubed root of y squared, close parentheses, times y to the 4th is written in the form y to the n, what is the value of n? Justify your answer. Let me start the timer. The one hint that I'm going to give you, you do have to say at some point n equals blank. A lot of students say, well, obviously that's n, so I should get 2 points, but you're not going to be explaining anything to the grader. they're not going to be with you at that point. If you forget to write n equals and then the number, you did not get full credit. You might get 1 point. However, you may find that this is an easy problem to get partial credit in. If you make a mistake, even if it's conceptual, but then you finally write n equals and then a number based on your conceptual error, you've got 1 point. Do not ignore the part 2s, 3s, and 4s. All right. Okay. When this expression is written in the form y to the n, what is the value of n? Justify your answer. We can check our answer by plugging in some random value of y and seeing if we get the correct answer. But I'm going to go ahead. So my estimate, I see that we're dividing by a positive power of y, which is not a whole number, not even close to 1. And then we're multiplying by y to the 4th. So the answer, so 3 is going to be between, n is going to be between 3 and 4. So that's my estimate. Again, a power of y in the denominator that's less than 1, power of y between 0 and 1, multiplied by a power of y that's equal to 4, that's going to give us a total power of y that's between 3 and 4. Okay, how do we do this? I convert this into a power, 1 over y to the 2 to the 1/3, that multiplied by y to the 4th. This is equal to 1 over y, 2 times 1/3, that to the times y to the 4th, and that's equal to 1 over y to the 2/3 times y to the 4th. And so then that's equal to y to the negative 2/3 plus 4. And that's equal to, now, can you put this as a decimal in your calculator? Yes, you're allowed for full credit, as long as you give the exact decimal. A lot of students get this wrong because they're so used to rounding and they get it wrong, okay? And so I'll explain that in a second. I'm going to do it with fractions. Y equals y to the negative 2/3 time plus, not times, plus 4 is times 3 over 3, 12 over 3. So this is equal to y to the 10 over 3. So notice that this would be 1 point. I did not say n equals. N equals 10 over 3. That is 2 points. Now, we do not skip this because you might have done this in the calculator, and you might have done negative 2/3 plus 4 and gotten this, okay? Gotten this. So let's talk about partial credit versus full credit. So not writing n equals a number, that's minus 1 point. Here's another one. Writing n equals 3.33, that's just minus 1. That's only 1 point, not 2. And you might be saying, but n is 3.33. No, it's not. N is equal to 3.33 repeating. That's 2 points. And they're not being cheap here. You do need to know that 3.33 not repeating is not the same thing as 3.33 repeating. In fact, that came up in the geometry grading. We were just grading a problem that's just like that. The question was, do you know that this is not the same thing as that type of situation? And that, yeah, so that happened. And it was a big argument. But the thing is, as the person leading the group, I had the unfortunate responsibility of telling people, like, I get it. We want to give kids the points. We know that they get it. But the grading is very strict. 3.33 and 3.33 repeating are not the same thing. And because these tests are normed, meaning that there's a massive training packet, literally 200-page training packet that we actually go through in like 2 hours to decide how to grade problems. Or if we have a lot of tests, we might go through it for 4 hours. Because we have to do that, it we all know that we can't grade 3.33 as 2 points when 3.33 repeating is the correct answer. My answer, this is also 2 points with all the work. Notice it says justify your answer. All the work is what gives me the 2 points. Número 29, number 29. The heights of the members of a ski club are normally distributed. The average height is 64.7 inches with a standard deviation of 4.3 inches. Determine the percentage of the club members to the nearest percent who are between 67 inches and 72 inches tall. Okay, I'm going to give you your minute. And I know that this is one of those problems that it's like you either know it or you don't type of situation. So some of you may be kind of just watching me, not, because you don't know how to do the problem. So I'm going to just put this here. And for a reason, for those of you who don't know how to do it. Now, if you don't know how to do this problem and you're about to learn it from me, then I appreciate you pressing the subscribe button, because that's how I make the tiniest amount of money off of this very, very free service. And as I said, since some of you are just watching, waiting for me to do it, do remember that there's a study guide in the description of this video. It's free to students. It's free to teachers. It's a very condensed set of sheets that you could do to master this Regents. And there's also a list of 20-minute problem sets that you could do literally every day for the whole year, including leap years, 366 days, that you could work on to master the SATs and ACTs. That is something that I tutor, by the way. I'm going to point to here, this button, distribution. That's where we're going to look. Okay? So my estimate, the average is 64.7. Both of these, 67 and 72, are past the 64.7. 64.7 is right here. So everything to the right of 64.7 adds up to about 50%, to exactly 50%. So since this answer and this answer, 67 and 72, are to the right of 64.7, this answer has to be strictly less than 50%. Now, I know the standard deviation is 4.3. 4.3 from 64.7 goes up to 69. So past 72, it's not that much of the data. But between 64.7 and 67, it's actually quite a amount. If I had to estimate, half of the data is contained in this ratio, in this shaded area, maybe half of the 50% that's on the right, 25%. That's a fair estimate. This is my estimate. But it's an estimate, okay? How do we actually do the problem? This is fully calculator and nothing else. Remember I said there's one problem that's fully calculator, nothing else? Technically, there was one other problem that was on the multiple choice that was technically calculator, but this one is so calculator. Above the vars button is the distribution, and it's in blue, so we press the second button and then press the distribution. We are going to normal CDF, normal cumulative distribution function. The lower bound is, well, between 67 and 72, the lower bound is 67. The upper bound is that 72. There's that Greek letter mu for mean, is 64.7. The sigma, the standard deviation, there's that sigma, is 4.3. And now we go to paste, enter, enter. Now, one of the things that I hate about the test, I feel like the moment you put the number in exactly, in this case, they should actually just give you 2 points. Copying something from the calculator, what is the value of that? I'm not sure. But they will not give you 2 points if you don't put the entire thing in the calculator. Ready? So what do I write for 2 points? I write what I just wrote on the calculator. Normal CDF, parentheses. Let me rewrite that down because there's no space there. CDF, parentheses, 67, comma, 72, comma, 64.7, comma, 4.3, equals 0.251580524. Okay? And they wanted it to the nearest percent. Now, this is a decimal between 0 and 1 instead of 0% to 100%. So I have to convert this into a percent. And so by multiplying by 100, this is approximately 25%. Right? 25%. 25, the number after the 5 is a 1, so keeps at 25%. That's a 2-point question. If you just write 25%, that's 1 point. If you write normal CDF of those numbers equals that whole number and approximately 25%, that's 2 points. Never been a fan of this type of problem, just writing the thing on the calculator, but I get it. I get it. I get why they're doing it. So that's what we do. And that's the way to get 2 points on that problem. So that said, numero 30, number 30. The explicit formula a sub n equals 6 plus 6n represents the number of seats in each row in a movie theater, where n represents the row number. Rewrite this formula in recursive form. Let's give you a minute for that. You kind of need to know recursive form and what recursive form means. You may be wondering, is something in the problem? Is there a formula in the back of the sheet that you can use? There is. Let me take that screenshot while I'm waiting. Two seconds. Okay, so I'm gonna put, there you go, dismiss that. So I'm gonna make a table real quick. Actually, let me switch colors. Let me go to blue here. Okay. So I can straighten that line, I guess not. So I'm gonna put n in this column and a sub n in this column. Okay. So n, 1, 2, 3, 4, 5, 6. And I get, well, if n is equal to 1, I get 6 plus 6 times 1, which is equal to 12. 6 plus 6 times 2, which is equal to 18. 6 plus 6 times 3, which is equal to 24. 6 plus 6 times 4 is equal to 30. 6 plus 6 times 5, which is equal to 36. 6 plus 6 times 6, which is equal to 42. If you don't believe that 6 plus 6 times 5 is equal to 36, you might just not be using order of operations correctly. But if you put it in your calculator, that confirms it. Some students would say that's equal to 60. It's not. 6 plus 6 times 5 is 36. Okay? That said, this is the arithmetic sequence in closed form. This is explicit form. Or some people call it closed form. Notice that this is an arithmetic sequence because I'm adding 6 after at every row number. So I'm adding a fixed amount per row. The pattern does continue. If you don't buy it yet, maybe it changes. Keep going down the list and see if it changes. It doesn't change at all. So what is the recursive form of an arithmetic sequence? Well, A1 is equal to the number, some number that you find. And then A sub n is equal to A sub n minus 1 plus the common difference D. So that's actually how to get to this answer. Now, if you didn't know that, well, you could actually just follow the table. So A6, how do you get to A6 from A5? How do you get to A5 from A4? Even if you didn't know that this was an arithmetic sequence, well, you could do it. So A1 is equal to, on the table, 12. And AN is equal to AN minus 1 plus, oops, let me put this in a subscript, minus 1, plus the common difference, which we're adding 6 each time, 6. This is actually it. I know I wrote it backwards from the way you're used to seeing it. A1 equals 12. AN is equal to AN minus 1 plus 6. That's our full and complete 2-point answer to this question. Número 31, number 31. Let me check if there's been any questions since. Nope. Okay, so number 31, numero 31. And by the way, again, will I be going through this whole test? Absolutely. So after I'm done with the whole test, and I'm giving you a minute to practice, so because my goal is to get you the highest score possible, including some practice time. So I am giving you some time to practice. I'm going to give you a minute to practice while I'm waiting. When I'm done with the video, feel free to go. It's going to post immediately. It's going to be there. So just rewind all the way to the beginning and just start. Start over and go. Number 31, express 2xi cubed minus 3y, all that squared in simplest form. I'm going to give you the minute. If you don't have an I in there, well, maybe, think about why not? A number with an imaginary part and a real part squared, not having an imaginary part, shouldn't happen. If it has a non-zero real part and a non-zero imaginary part, and you square that, that number will have a non-zero, an imaginary part, guaranteed. Guaranteed. And if the real part and the imaginary part are incommensurable, as variables are incommensurable, if you don't know what that means, variables are incommensurable with each other because there's no way to write like a generic y in terms of a generic x. A generic y in terms of a generic x. Then you're guaranteed to have a real part and an imaginary part. Okay. So, how did I did this on paper by just squaring this out, but I think it's just better to fix this one thing. I cubed is equal to negative I. And we spoke in earlier part of the video, although I know that not everyone joined at the beginning of the video because this is live. I'm literally right now, I don't know how much of a delay is. It's a few seconds. I don't know how much of a delay is. But you see it's 4:58 p.m. on June 23rd. I'm literally doing this live. So I think there's about a 30-second to a minute delay. So, but I told people that there's an I button on the calculator right above the decimal in blue. So if you press the blue second button and press the decimal for an I, take that to the third power, it's negative I. Well, that confirms it. So I'm going to replace the I with a negative I. And so what I'm squaring is 2x times negative I, so negative 2xi minus 3y, that's squared. And I'm going to use the box method. I'm a big fan of the box method. Okay? Negative 2xi, negative 3 minus 3y, negative 2xi, minus 3y. And I see negative 2 times negative 2 is 4. X squared is just x squared. I squared is going to simplify to negative 1 eventually. Negative 2 times negative 3 is 6. X times y times I. And then I got another 6x, y, I. And then now negative 3 times negative 3 is 9. And y times y is y squared. And then I add, and I can combine like terms now, might as well. I get 4x squared, I squared is negative 1. I could also simplify right away. I can combine the 6xyi and the other 6xyi, so plus 12xyi plus 9y squared. And so I get negative 4x squared plus 12xyi plus 9y squared. Now, some students may want to put the real part and the imaginary part in that order. So this is a 2-point answer. But also, if you decided to say equals negative 4x squared plus 9y squared plus 12xyi, and you gave this as your answer, it's also a fully correct 2-point answer. Groovy. And if you make a conceptual error at this point, you get full credit, you get partial credit. So do understand that partial credit on this test is so many points. That's actually the big benefit of the part 2s, 3s, and 4s. So if we do a quick count, there's 24 multiple choice questions, each for 2 points. That's 2 times 24 is 48 raw score points on the multiple choice. Then on the part 2s, 3s, and 4, we got 2, 4, 6, 8, 10, 12, 14, 16, 18. Now, these are now worth 4. So 20, 24, 28, 32, and now 30. This one's worth 6, so 38. So 38 points on the part 2s, 3s, and 4, 48 points on the part 1s. They're about the same size. It's like a 4/7 ratio, you know? That's really close to 1/2. So, and not only that, like if you can pass on just the part 1s, you can actually pass on just the part 2s and 3s and 4s. And the truth is that if you can pass on the part 1s showing work, you can get an 80 using the part 2s, 3s, and 4s. So do you skip the part 2s, 3s, and 4s? Very much no. Verily, I say to you, no. Okay. Where are we? 32. Número 32, number 32. A survey was given to 1,250 randomly selected high school students at the end of their junior year. The survey offered 4 post-graduation options: 2-year college, 4-year college, military, or work. Of the 1,250 responses, 475 chose a 4-year college. State one possible conclusion that can be made about the population of high school juniors based on this survey. And I'm going to give you your minute. For those of you who have never seen a problem like this kind of question, while 48 seconds while you get to practice on this, this kind of question will ask, it's going to be a survey of some group of people. That group of people is going to be restricted in some way. That implies that the survey is only valid for that restricted set of people. You might ask 14-year-olds coming out of an action movie. Well, then the survey is only valid for 14-year-olds coming out of an action movie. Or you might ask about juniors in New York. Then the survey is only valid for juniors in New York. Or you might ask teachers in one high school. Then the survey is only valid for teachers in that high school. So, in this case, the survey was given to 1,250 randomly selected high school students at the end of their junior year. There is no restriction other than the fact that they're juniors, that they're students in high school at the end of their junior year. So this is nationally high school juniors all over the country, end of junior year. survey offered these 4 options: 2-year college, 4-year college, military, or work. Then of the 2,250 responses, 475 chose a 4-year college. I'm going to do 475 over 1250 in my calculator. That's 38% or 0.38. It's exactly that. That's unrounded, 0.38 or 38%. What can we say? Well, all we can say is what the survey says about the population that the survey is restricted to. So that means that based on this, approximately 38% of high school juniors would choose which one was this again? 4-year college. 4-year college over the over all 4 choices given. And you could even say, and 62% would select one of the 3 other options. It can feel like you literally just, in this case, just repeated what the problem said to you. And I will say this, you kind of did. You literally kind of did. That's actually what the question is doing. Can you take a survey result, look at who was polled in the survey, and identify the population for which the survey is valid? The survey is only valid for the population that was surveyed. If you ask high school juniors, but you ask the first 1,250 high school juniors who arrive at their school, in other words, the very first kid who arrives at the school in 1,250 schools or something like that, now you're surveying only the students who get to school early. Or if you're only asking high school juniors coming out of a comedy movie, or you're asking only high school juniors who are attending local pools during the summer. It's only valid for those kids. That's literally, so it's literally asking, can you identify the correct population and what the survey implies? All right, now we are at a 3-point part 3 problem, which is a 4-point problem. Each answer will receive 4 credits. Now, each of these, if you ignore these, that's to your peril. Each of these is worth 4 credits or literally 2 multiple choice questions. That's why I repeatedly say putting focus on the part 2s, 3s, and 4s is 100% worth it, because because partial credit is very friendly. This is a 3-part problem, which means that the points might be split like 2-1 and 1, or 1-2-1, or 1-1-2. If there's one part that you don't know how to do, but you use that work to do the other 2 parts, then you could still get 3 points often, or sometimes 2, or depends on the situation. Each part provides points, which means that you can get an enormous amount of them. Again, the thing about the diagrams not drawn to scale, not necessarily drawn to scale, I always talk about that part. Don't assume that they're not drawn to scale. That's not a good assumption. But then the other way around. Also, if you actually confirm that it is drawn to scale, then you can use the scale. But so that's even better. But what happens if you get to a diagram and you can't confirm that it's not drawn to scale, and you don't know how to do the problem at all? Well, if you actually do assume that it's drawn to scale, you may find that you actually can get a lot of points out of it. So, but again, this test is weird in that it doesn't have any diagrams that can even be drawn to scale. I've never seen that. Uh, so this test does have 0 diagrams not drawn to scale. All diagrams are drawn to scale. Okay. Número 33, number 33, a researcher, and I'm going to give you practice time for each problem. Okay, número 33, number 33. A researcher wants to determine if nut allergies and milk allergies are related to each other. The researcher surveyed 1,500 people and asked them if they're allergic to nuts or milk. The survey results are summarized in the table below. And I see quick table, allergic to milk, not allergic to milk, allergic to nuts, not allergic to nuts. Determine the probability that a randomly selected survey respondent is allergic to milk. So when I now go to the table, I go back to the table and read it again to get the information in. Allergic to nuts and not allergic to nuts, okay? And separately allergic to milk and not allergic to milk, and I see 342, 12, and 1443. It said to determine the probability that a randomly selected survey respondent is allergic to milk. I'm going to give you that minute. Allergic to milk. That's not necessarily an uncommon allergy, believe it. It can be caused by a few different things, and relevant for you students who are either parents now or maybe becoming parents at some point between now and later. There's a little bit of research that shows that one of the reasons that milk allergies may be occurring is not actually just the fact that kids, very small kids, are being fed milk at too early of an age. It does turn out that allergens can become, or potential allergens can become potential actual allergens if you get exposed to them, but not as a food item, but physically. And so how could a baby get exposed to milk on their skin? Well, if the baby's not drinking cow milk, but you're drinking cow milk and you have cow milk on your skin, cow milk on the surface, and they get a little bit of cow milk on their skin, they can actually develop an allergy to it. So do follow the recommendations about when kids can be exposed to milk, cow milk, but also avoid physical contact with the item until it actually can be ingested by the kid. Otherwise, they might actually develop an allergy when they might not have it in real life. Anyway, so determine the probability that a randomly selected survey respondent is allergic to milk. So now we're looking at all the respondents. We do know that it's 1,500 respondents, but just to confirm, we are looking to see if they're allergic to milk. So we are going to the people who are allergic to milk. So we got 3 plus 42 are allergic to milk. And out of the whole respondents, we got, well, in the denominator, we could do 3 plus 42 plus 12 plus 1443. That's everybody. And not surprisingly, the numerator is equal to 45 over, and the denominator is 1,500, which is what we should have expected from the fact that they gave that to us. And that's equal to 0.03. And you could do that as a fraction, you could do 300ths, or leave it as a decimal. Okay, so the second part, now that we know how to calculate that, see if you can calculate determine the probability that a randomly selected survey respondent is allergic to milk, given that the person is allergic to nuts. So we got about 47 seconds left on that. Think about what that means, though. You may find that you could actually get your partial credit on this, or your full credit on this part. The first part and the second part are very similar to each other, and I want to give you the time to practice it. Determine the probability that a randomly selected survey respondent is allergic to milk, given that they're allergic to nuts. 17 seconds. Think about what number you want to put in the numerator, the number you might want to put in the denominator, given that they're allergic to nuts. Given that they're allergic to nuts. 5 seconds. So the probability the probability that they're allergic to milk, given that, this is where we put a vertical bar, given that given that they're allergic to nuts, is equal to the fraction, so this is for you, the fraction allergic to milk only among those with nut allergies. Okay, so that's what that means. I need to scroll a little bit, bring this down. Okay, if it lets me. There we go. And so, well, that's equal to among only the people with nut allergies. We're looking only here. And the allergic to milk is just 3 people among the people with nut allergies. 3 over 3 plus 12 is equal to 3 over 15. And you can leave it this way, but I recommend simplifying because you do have to compare later on the answer above and the answer below. 0.2. 0.2. Got 0.03 in this one, 0.2. Okay, I'll give you a little bit of time to see if you can come up with a justification. Based on the survey data, determine whether nut allergies and milk allergies are independent events. Justify your answer. Justify could include words as an explanation, and it also can include just the algebra. Justify. But you do have to say yes or no, no matter what. Okay? Okay, so let's talk about this one. I'm going to just define what independent events are. A and B are independent events if and only if the probability of A is equal to the probability of A given B. In other words, the probability of A is equal to the probability of A given that B is true. Okay, that's actually the definition of an independent event, of independent events. There are other definitions, like for example, if P of B is equal to P of B given A, then they're independent. And equivalently, if the probability of A and B happening simultaneously is equal to the product P of A times P of B. So there's other definitions, but let's use this one because this is the one that the Regents is obsessed with. Since the probability of allergic to milk equals 0.03 does not equal the probability of allergic to milk given allergic to nuts, which is equal to 0.2. So 0.03 equals does not equal 0.2. So these events, allergies, are not independent. And so that's a 4-point response. There's a lot of places to eke out points here. Get the first answer, 1 point. Get the second answer, another point. Explanation here, 2 points. Do all of it, 4 points. Do all of it, but make a mistake in this part, and then make exactly the same mistake in the second part. They only penalize you once for that error. So you can make a mistake twice and get penalized exactly once. So that's a big deal. Numero 34, number 34, and this is a 2-point question. Algebraically solve for x. 2x equals 6 plus 2 radical x minus 1. So I'm going to give you your minute to start it. This is a 2-point problem, a 4-point problem. Somehow, even though it looks kind of simple-ish, to me at least, it looks simple-ish. Yeah, let's start the problem because you want to get your partial credit. You want to get your full credit. You make one mistake, maybe 1 point. Make a second mistake, maybe 2 points. make the same mistake twice, we do analyze the mistakes for what they are. What is the mistake that the student made? If it's the same mistake twice, then we don't penalize twice. 25 seconds. The moment I see a radical, I'm starting to suspect extraneous solutions. On the left, I see y equals 2x. On the right, I see 6 plus 2 radical x minus 1. So shifted to the right one space. Here's 6. Here's 1. So it's going to look like that. It's going to cross exactly once. It's going to be one solution. So this estimate, one solution. So let me just clarify here what just happened here. So the second graph that I made is the 6 plus 2 radical x minus 1. The yellow graph is y equals 2x. So two different functions, they cross exactly once. There's going to be exactly one solution. And it's going to be not too far away. I mean, not too far away from 1. So how do I do this though? Minus 6. So I suspect strongly there's going to be an extraneous solution, but let's see. 2x minus 6 equals 2 radical x minus 1. Let me see if I can move this over a little bit, because I'm going to need the space. Okay. So I divide by 2. In other words, I'm trying to get rid of this radical. I got x minus 3 equals radical x minus 1. Now I'm going to square both sides. So, and about this squaring both sides, this is where it becomes important. The moment I squared both sides, I performed the action of squaring both sides. I created potential extraneous solutions. Extraneous, I'm going to scroll down here because I'm going to scroll down later. Solutions. So I'm required to check my answer. And this is not like my teacher makes me check my answers type of thing. This is not like my tutor says I should check my answers. This is actually the algebra physically requires you to check your answer. The moment you perform an information destroying operation, and that includes the squaring operation and any other operation that's not one-to-one, or any operation that maybe is or is not one-to-one, but maybe is missing part of the domain of, or part of the real numbers as part of the domain, the moment you perform any information destroying operation, you're required to check your answer. The algebra requires it. So now I squared both sides and I get x squared minus 6x plus 9 equals the square root of x minus 1 squared. So x minus 1. Subtract x, subtract x. And I could add 1 right now, but I'm gonna do that after. X squared minus 7x plus 9 equals negative 1 plus 1 plus 1. I got x squared minus 7x plus 10 equals 0. Now I happen to see that I can find two numbers that add up to 7 and multiply to 10 right away. So blank plus blank equals b over, so negative 7. Since a is equal to 1, I could just start that way, and blank times blank equals to 10. And the numbers that add up to negative 7 multiply to negative 10. So factor rainbow 1 and 10, 2 and 5. So negative 2 and negative 5, and negative 2 and negative 5. Okay. So I could factor this as x minus 2, x minus 5 equals 0. And I have to keep going. Remember, this is not my teacher requiring me to check my answer. This is the actual algebra. The method itself actually requires us to check our answer, okay? So factor the zero product property. Since the product is equal to 0, one of the factors is 0. X minus 2 equals 0. Plus 2 plus 2. Okay, x equals 2. And x minus 5 equals 0. Plus 5 plus 5. And I got x equals 5. And according to the graph, I don't know which one of these answers might be extraneous or not. I'm surprised. Like, often students are like, both answers are positive. Both answers are positive, so both work. No, not in this case. I love this question because so often the Regents makes it so that what the answer that's not valid is like negative, and students get into the habit of just deleting the negative answer and calling it extraneous, and that's just not right. And it's a bad habit created by the creators of the Regents test. And so now we're going to have to check. We have to check. Remember, now I'm gonna take a screenshot of this because now I have to scroll down. This is the original equation, right? Now I hope I don't lose electricity. It just started to rain over here where I'm at, so I hope that I don't lose electricity. But I'm checking x equals 2. 2 times 2 equals 6 plus 2 radical 2 minus 1. This is not looking good. So I got 4 equals 6 plus a positive number. 2 radical 1. I got 4 equals 6 plus 2. I got 4 equals 8. This is not true. So x equals 2 is extraneous. And here, x equals 5. I got 2 times 5. 2 times 5 equals 6 plus 2 radical 5 minus 1. So I got 10 equals 6 plus 2 times radical 4. 10 equals 6 plus 2 times 2. I got 10 equals 6 plus 4. 10 equals 10. So x equals 5 is the only solution. If you get to the point where you get 2 and 5 and you don't recognize x equals 2 as an extraneous solution, you actually get 3 points, which is great. So I would not give up on this problem. If you get to the point where you make an algebraic mistake and you get 2 totally different answers, but you make one algebraic mistake and you don't check for extraneous solutions, depending on the error, if it's considered to be an arithmetic error, you lose a point. If it's considered to be a conceptual error, you lose half credit, 2 points. But either way, if you make a conceptual error and you forget to check your answers, then you get a point, which is half a multiple choice question. That's enormous. For a 4-point problem, to get a full half a multiple choice question, that's a big deal. Número 35, number 35. I might actually rush through these a little bit because I know we lost power because of a storm yesterday or 2 days ago. So I'm gonna not give the minute for this one. I'm gonna make the executive decision. During the summer, Adam saved $4,000 and Betty saved $3,500. Adam deposited his money in Bank A. Again, it's raining. At an annual rate of 2.4% compounded monthly. Betty deposited her money in Bank B at an annual rate of 4% compounded quarterly. Write 2 functions that represent the value of each account after T years if no other deposits or withdrawals are made, where Adam's account value is represented by A of T and B, and Betty's is B of T. And this is the formula. A equals P times 1 plus R over N to the power of NT. This is P principal, the initial deposit, R, the interest rate, and the number of times compounded. Number of times compounded. So every 3 months means quarterly, 4. Every month means monthly, is 12. And T is time in years. And also A equals P E to the power of RT. This is compounded continuously. and this is compounded n times per year. Okay, so now A of t is equal to, well, A of t is Adam's balance, is 4,000. That's the principal deposit. Now, 1 plus R is the interest rate that that bank A is gaining, 0.24 divided by its compounded monthly, so 12, to the power of then 12 times t. Okay. And then, so that's my points. I don't have to simplify. Yes, can I simplify? 0.024 divided by 12 is 0.002. I don't have to do that. B of t is equal to, well, that's 3,500 times 1 plus, now the interest rate that Betty is getting, so Betty, again, 3,500, interest rate she's getting is 4%, 0.04, compounded quarterly, 4 quarters per year, divided by 4 to the power of 4 times t. And do I simplify 0.04 divided by 4 is 0.01? No, I don't have to. This is 2 points. 2 points. I've gotten my 2 points. Okay? Using technology, determine to the nearest tenth of a year how long it will take for the two accounts to have the same amount of money. Justify your answer. So they tell you to use technology, but justify your answer. Use technology, but justify your answer. So you have to tell us what you're going to put into your technology. So how long it's going to be until the accounts have the same amount of money? You have to check when they have the same amount of money. So what you have to put into the calculator, 4,000 parentheses 1 plus 0.024 over 12 to the 12t equals 3,500 times 1 plus 0.04 over 4 to the power of 4t. So this is what I'm putting into the calculator. And so that's what I'm going to put. I'm going to scroll a little bit. Get my big screen. Notice that I had to write, again, I had to write what I'm going to put in the calculator. If I don't write what I'm going to put in the calculator, I don't get the full credit. But I get a point, which is good. I think I'm all the way down to 9 and 10. Is there 9 and 0? Okay, good. So 4,000. Okay, I'm going to undo that. 4,000 parentheses 1 plus 0.024 over 12 parentheses to the power of 12x. And then the second one is 3,500 parentheses 1 plus 0.04 over 4 close parentheses to the power of 4x. Now, I know if I do Zoom standard, I'm doing Zoom standard, but just to readjust everything, like the x and the y axis to be from -10 to 10. But I know that these numbers are going to be above like 3,000 and 4,000. So I'm actually then, after it's done, I'm going to do Zoom fit. Now, if they don't cross on this graph, then I might do Zoom out afterwards. But it does turn out that they're going to cross early on. So valid times before time equals 0 aren't valid because they deposited at time 0. They cross right there, which is great. So I don't have to zoom out. How do I calculate the intersection? I could literally go to calc in blue. So I press the blue second button and press calc right above the trace button. I'm going to calculate the intersect. Enter. The first curve, enter. The second curve, enter. And I guess, so I get close to that number. I do actually suggest you guess. I know a lot of teachers say don't bother, enter. But I see the answer is around 8. And there's my answer, 8.437. And so what do I do? What's my new muscle memory thing that I taught students in this video? I only started this in the last like 2 weeks with students. So I got that t. Notice this says x, but the variable I'm using is t. T If you actually replace the t with an x, that's a point off. I hate that, but it's a point off. T is approximately 8.4378473. They said now to the nearest tenth of a year. So that's the second part. First part is write the full answer that the calculator gave me. Second part is underline nearest tenth of a year. The third part is to actually do that rounding, like they said, 8.43. The 3 is below 5, so I would keep the 4. Do I give the units? No. Tenth of a year. They asked tenth of a year. I gave tenth of a year. I got my points. The rain is cooling down, so I'm still gonna. I don't know what it's gonna do after this, so I am gonna not give the full minute. So I'm just gonna keep going on this one, just like I did with number 35. I gave you a full minute on the full test. Do understand, once this video is done, so if you're watching now, once this full video is done, I want you to then go and back to problem number 1, because this video is gonna be live instantly, right after I'm done with it. It's all there. So you can go right at the beginning and start with problem 1 and ask all the questions that you have. And they'll all, I give hints for process of elimination. I give hints for guessing strategy. I give hints for when to use the calculator. Lots and lots of things that I give you. I want you to get the best grade possible. Also, you should be showing work on the part 1s so that you can get the points on the part 1s through part 2s, 3s, and 4s. On the graph below, draw at least one complete cycle of a sine graph passing through the point 0,2. So they tell me that it passes through the point 0,2. I'm going to put a dot there. And has an amplitude of 3. But where does it go up to or down to? I don't know yet. It has a period of pi. So since it has a period of pi, I know it's going to go through the point pi, comma 2. And the midline at y equals 2. So that's a gift. It's going to have a midline at y equals 2. So it's going to go up to 5, amplitude of 3. And down a trough at -1. So it's got a period of pi, which means it goes through one cycle from 0 to pi. And it only wants one cycle, at least one cycle. You could draw more cycles. So, and it's a sine function, a sine graph. So it starts at 2, goes up, down, all the way to the bottom, and back here. So it's going to cross there. It's going to go up to here and down to here. And so then I graph this. Looks almost parabolic there. And then the next piece also almost looks parabolic. So if you're wondering how to graph it nicely, if you just pretend that you're drawing a parabola, it's actually a good strategy. There we go. I drew exactly one cycle. They said at least one cycle. I drew exactly one cycle. Lots of students draw more than this and they make a mistake. Do you have to label your graph? They just told you to graph it, or no. However, if you do label the graph, you could label the graph with the correct function. If we have two functions that we have to graph simultaneously, then yes, you absolutely do have to label the function. Now, based on the graph, that's 2 points. Based on your graph, state an interval on which the graph is increasing. It means the graph is going up. Here's an interval where the graph is going up. Here's another interval where the graph is going up. So if you give any of those intervals, you get another 2 points. So I'm going to say parenthesis 0 to this point, which is pi over 4. Pi over 4. That's 4 points. That's 4 points. Not bad. Not bad. Does neatness count on the graphs though? Yeah, neatness counts on the graph. If your peak is in the wrong place, if your trough is in the wrong place, if your point 0,2 is not drawn, you can lose points very easily on this graph. So the one thing I tell students is that, like, we know that your A can look like that, or can open up a little bit. Your A could sometimes look like a U. So if you do, I mean, A can look crazy, right? But a graph means what it means. So the location of points on the graph really, really very much matter. So neatness does count because of that. So if a peak is reached at a certain point, put the peak at that point. Okay, this is a full 4-point problem. Number 37, número 37. I'm gonna again go through this one, but I am gonna quickly say that diagrams not necessarily drawn to scale. You know what I've said about scale so far. Just because it says not necessarily drawn to scale doesn't mean that it isn't drawn to scale. I don't know what the test is going to look like tomorrow. This is the first test that I've seen that no diagram is even capable of being not drawn to scale. That was weird to me. So this test has 0 diagrams not drawn to scale. Every diagram is drawn to scale. But I don't know what the test is going to look like. Maybe some diagrams are maybe doubtfully drawn or not drawn to scale. If you assume it's drawn to scale, that may actually be more likely to get you the right answer. But vice versa, if you actually check whether it's drawn to scale, that does even more, because if you confirm that it's drawn to scale, then you could use scale. And vice versa. But if you get to a problem that you don't know how to do, but you assume that it's drawn to scale, like you don't know how to do it, and you don't know how to confirm whether it's drawn to scale, but if you assume it is drawn to scale, then you can use that, especially on a multiple choice, to get a lot of points. And that includes part 2s, 3s, and 4s. Number 37. This is the last problem. I want to thank you for getting through this video. It's a long one, and the reason I did the video this way is so that you get time to practice, but you also get hints. You get methods of eking out every single possible point from the part 1s, part 2s, part 3s, part 4s to maximize your score. I have tutored students exactly how I'm doing these videos, and I've gotten them from 50s to 80s. I've gotten them from 60s to 85s. I've gotten from 80s to perfect grades, from 80s to 98s, from barely passing to college credit. So the advice that I'm giving you in this video, do take it to heart. If you feel that the work that I've done is worthy of your subscribe, please do hit the subscribe button. It's how I know that the job that I'm doing is good for you. Okay. Number 37, a manufacturer of sweatshirts finds that profits and costs fluctuate depending on the number of products created. Creating more products doesn't always increase profits because it requires additional costs, such as building a larger facility or hiring more workers. The manufacturer determines the profit, P of X, in thousands of dollars as a function of the number of sweatshirts sold, X, in thousands. The function P is given below. P of X equals negative X cubed plus 11X squared minus 7X plus 69. Graph Y equals P of X over the interval 0 to 9 on the set of axes below. I would love to give you the minute, but again, because I don't know what this storm is going to be doing, I'm just going to go ahead. This is one where, like I said, neatness matters. One thing you got to remember, they did say that P is in thousands, and they said that X is in thousands. But so X equals 1 represents 1,000. P equals 1 represents 1,000. P equals 30 represents 30,000. Also, you got to recognize that they actually marked the graph for us. They don't have to do that, but X equals 1 is marked, and Y equals 30 is marked. Okay? I've officially run out of space to graph. So I'm gonna undo these graphing, but I'm not gonna delete those. I actually purposely keep those and every graph that I used, except for, of course, it fits 10. So I'm gonna delete the first one. P of X then equals negative X cubed plus 11 X squared minus 7X minus 69. Now I'm going to go to my table, which is above the graph button in blue. So I press the second button and then press table. And I can scroll up and down. Remember, they said from 0 to 9. So let's talk about places where students lose points. First, 0, comma, negative 69. 0, comma, negative 69. So this is negative 30. This is negative 60. Let me try that again. Negative 60. This is negative 90. So where students lose points, negative 75 is right in the middle. So negative 69 is right there. One place where between negative 60 and negative 75, but closer to negative 75. One place where students lose points is they do this arrow. That's a point off. That's a point off. And you would think, how could that be a point off? The graph can continue. And when I graph it on the calculator, the graph does continue. Well, this problem says between 0 and 9 inclusive. 0 less than or equal to X, less than or equal to 9. You have to stop at 0. Next, and I'm actually going to drag the table over to here. Actually, I'm going to make it lighter. It gets dark randomly, right? Because, actually, I'm going to scroll to get all the numbers. So, Another place where students lose points is that when they get past 9, they put an arrow at the end there too. And that's actually points off. Okay? So I'm going to do that, and I'm going to graph my points. So 1, negative 66. 2, negative 47, slightly below negative 45. Now I'm going to do 2, 3. I'm going to mark that in blue so you can see it better on your screen. 2, 3, 4, 5, 5, 6, 6, 7, 8, 9, 10. And mark 9 because I'm going to stop at 9. Okay? So let's do this. 3, negative 18. Just below negative 15, 4, 15. That's exactly on the line. That's another place where students lose points. They know that it's exactly like on that X, but they're like, oh, it's easier to see if I just move it over. Up, down, left, right, but you can't move it over. You actually have to show it on the line because that's where it's located. So yeah, that's put it exactly where it's supposed to be. 546, 545. So let's put these other numbers again. 60. 90. Let's put those numbers there. 546. That's just above 45. 669. 6 is closer. 69 is closer to 75 than to 60. 778. 7 just a hair above 75. 8, 67. Just below 69. This doesn't have to be so perfect, but know that it's below 69. Then 9, 30. And I want to point out that's exactly on the dot on the X. And I stop there. And then what do I do with these numbers? I connect them. Now, another place that students lose points is they get their straight edge out. That didn't draw a straight line, but they get the straight edge out. That's illegal because this curve is not straight. It's curvy. So we follow the points, follow the points, follow the points, follow the points. Carefully, carefully, carefully. And we stop at 9. So we stopped at 9. I'm going to do that one in red again. Why does it keep doing that? And stopped at 0. Okay? That's a full 2-point graph. That's a full 2-point graph. Neatness actually matters. Now, what things do I require on the axes? Since they only gave me one function to graph, I don't have to label this as P of X. Since they gave me the numbers 30 and 1, they skip counted by 30. I'm required to skip count by 30. And 1 on the x-axis, so I am required to use skip count by 1s. If I change that, I can lose points. The points have to be where they're located, and I have to draw with a smooth line, and I cannot go below 0, x equals 0, and I cannot go above x equals 9. Okay, so number 37, continued over the given interval, state the coordinates of the maximum of P and round all values to the nearest integer. Explain what this point represents in terms of the number of sweatshirts sold and profits. Okay, now the maximum seems to be around x equals 7. Granted, and it is going to turn out to be x equals 7, but that's not a safe assumption. We have to go to the graph, and we notice that it has a weird graph, okay? But I'm going to change the window. I could either change the window negative 90 to 90, and I could even change my x min and max. So I press the window button. You can always reset this by doing zoom standard. I'm going to change my window from, I'm going to do -1 to 10. So it includes 0 to 9, but it also includes a little bit before and a little after. But I'm going to change my y min from negative 90 and my y max to 90. Okay, now I'm going to graph this. And I confirmed that I actually did the graph really well. Notice again, this graph went from included -1 to 0, so that's missing on purpose. And then from 9 to 10, that's missing on purpose also. So how do I get that max? That max, I get it in the blue calc button above trace. So I press the blue second button and press calc. Get the maximum 4. I go to the left of that maximum. I go to the right of that maximum. And then I actually guess at the maximum. I do recommend guessing at the maximum. Yes, you could just press enter, but I do recommend it for a lot of good reasons. And I get 6.999992. This is one of the annoying parts with calculators. It says 6.9992, but if the answer is extremely close to an integer value, the thing is that the calculator uses floating point arithmetic to get to the answer. The algorithm eventually stops when the algorithm stops producing more accuracy. It stopped producing accuracy once it got to y equals exactly 78. And then it ran the algorithm again and just got right back to 6.999992. You have to know that that actually means 7. So the maximum at the point, it says state the coordinates. Let's just make sure I did that. Maximum at 7, 78. If you put 7,000, 78,000, that's minus 1. Because X is number of sweatshirts in 1,000, P is the profit in 1,000. So X is 1. X is 7 means 7,000 sweatshirts, but the coordinate is 7. And Y is 78. That does mean 78,000 sweatshirts, but Y is 78. Now explain what this point represents. Excuse me, in terms of the number of sweatshirts sold and profit. I would love to give you the minute, and the storm seems to be going away, but I don't want to lose electricity. So I'm just going to keep going. The number of sweatshirts and profits. This means this is the maximum at the graph. This is at the maximum. So you do want to express that that's a special point. You don't want to just say that when 7,000 sweatshirts are sold, a profit of 78,000 is gained, but also that that's the maximum. So this means that when 7,000 sweatshirts are sold, profit reaches the maximum of $78,000. Now you notice that in most cases, I actually recommend not giving units, but in this case, I gave units because they asked me what it represents in terms of the number of sweatshirts sold and the profit. They actually told me to explain what it means. So yes, I had to explain. Okay, that's 2 more points. If you give the maximum 7, 78, that's a point. If you give the explanation correct, that's a point. If you forget to give the coordinates, or you give the coordinates as 7,000 and 78,000, and then you give a correct explanation, that's 1 point because the coordinates are 7, 78. Okay. The last piece, and again, this is it for the studying and the doing of this whole test. So I'm going to repeat again, and thank you for being here. I know that we have a lot of viewers already, but a lot of viewers came in, but once we finish this problem, I recommend going to the very beginning and watching from problem 1. This is going to be uploaded automatically. It's not going to disappear. It is going to stay there, so you don't have to worry that it's just going to disappear all of a sudden. It's going to be there the whole time. I want to thank you for being here. Again, I appreciate the subscribing because that is how I make a little bit of extra income from these very few videos. I did this because there was a point in my life where I could not afford, nor could my parents afford any amount of tutoring. And now I do tutor for much more discerning clients. I've priced out, unfortunately, a lot of clients who look like me and have lifestyles that were like mine when I was a kid, poor to lower middle class incomes. So this is something I provide for free. The way I get something out of it is by your subscribing. So please do that, and then I can keep putting out videos. The last piece, and then we're done. And I know you could do this, and you just got to show work, and you can maximize your score. Determine how many sweatshirts to the nearest whole sweatshirt the manufacturer would need to produce in order to first make a positive profit. Justify your answer. I am going to give a sentence here, but this is what we're noticing. At all these points, the company, the manufacturer is selling sweatshirts here. Selling, but they're not making a profit. And you might be wondering, why are they selling if they're not making a profit? Well, the reason they're selling is because they want to eventually be up here, right? Making a profit. So we have to find out where the profit goes from this. I'm going to put in red because often red profit means negative profit. Where it goes from being red to being in the green, meaning having positive profit. So that's the point that we need to find. That's the point that we need to find right there. Okay? So how do I find it? I go to the calculator. That's the zero of the polynomial. Notice that a big question in finance literally boils down to finding a zero of a polynomial. So again, in blue, above the trace button is the blue calc button. So I press second and then calc. I'm going to calculate the 0, 2, also known as the root. I go to the left of the root, enter. I go to the right of the root, enter. This is why I recommend doing the guess. When you do the guess as close as you can get, the guess ends up being more accurate. That's the reason. So if your guess is way too far away, my biggest fear is that maybe the rounding error is too big. That's just my fear. That there's no guarantee of that. But I do know that when you do guess, the guess is a lot more accurate. And you get this as your guess. Okay? Now, you have to remember, again, that the X is in thousands of sweaters. So if X is in thousands of sweaters, we're going to have to round X to the nearest thousand so that we can multiply or look at the nearest thousand and know that we need to get the next number above this X value to have a positive profit. So we have X is equal to, and remember what I said about rounding, 3.5488398. So this equals 3,548.8398. 0.8398 sweatshirts equals 0 profit. Okay, exactly 0 profit. And that means when 3,549 sweatshirts are sold, and I didn't round up because of the 8. Yes, there's an 8, but I rounded up because I had to round up because the profit is increasing. If this was 3,548.2, I'd still round to 3,549. When 3,549 sweatshirts are sold, that will be the first time. Sweatshirt, should I say produced? Now, I did check the grading. It does say produced, but I did check the grading. If you said sold, it would still be accepted. That will be the first time that a positive profit is made. And that is 6 points, and that is a 100-point Regents. Listen, I know you're able to do this. I have full confidence in your ability to do this. If you're getting close to a 65, you got to show work. And if you show work, show work on the part 2s, 3s, and 4s to get you to an 80. If you're borderline 65, you can get an 80 for sure. Go through the problems. I highly recommend writing the problems exactly as I wrote them, and study every problem. Any problem that you didn't understand, just redo those. Okay? And that's what you will, if you do that, that's what you could do to get to a perfect grade. Or if you're at an 80, to get to a 80 if you're at a 65, and to get to a 65 if you're hovering around a 40. I fully believe in you. I know you can do it. You're going to do great tomorrow or whenever, if you're taking a future Regents, whenever your Regents is, but if you're taking the June 2024 Regents, that is tomorrow. I believe in you. Go to problem one, go to the beginning of the test, the video, and redo any problems that you missed. If you just got to the video, restart at problem one and do all the problems. All right. Have a great day. Good luck tomorrow.